designed because of its power, efficiency, and size, and portability too.
Oh, yeah.
Yeah, Kenny, that actually might work.
There's three different types of 12 volts here.
All right, so let me put that down. Maybe you plug one of those up. Here, let's see. Here, take this. See if it fits on the. I think it's got a diode in it, so the polarity won't get messed up.
Are you doing?
You doing the video for the club? I'm trying live streaming.
Okay.
So we got two things going.
He's doing the Periscope thing.
Oh, okay.
Yeah.
So
Let's just go
you're
ahead
not
and.
recording.
No.
Okay.
I mean, none of this is ideal. I'm crammed in a small space. I don't have my normal toolkit with me. But I was going to start with talking about soldering for doing through-hole capacitor replacement. So I got this jumbo board that takes up way more space. So this is a guy's out of Florida. This is his board. Lots of battery damage, corrosion in a lot of the ICs. The 68000 had solder or had corrosion on the legs of the board or on the chip. And in order to get all the corrosion out, what we had to do is kind of remove a lot of the ICs around here and then use what's called a scratch brush or a, let me put this on the screen real quick. This is a fiberglass brush. It's kind of like a pencil configuration. Like you can see it's got a long pencil-like mechanism, but it uses fiberglass. And this is really good for removing corrosion and cleaning legs off of pin on connectors for when you've got like tarnish around your DB23 ports for your video. This is really good for removing some of the tarnish that occurs, the oxidization, and it gets it back to raw metal. But it's possible to actually scrape off all that and get down into the more tin parts of the connector itself. But this is a really good thing I use for cleaning up. But yeah, getting this guy's board back in shape meant removing all of the solder mask and exposing the traces. And to do this, you had to get to a lot of the IC, so you've got a couple of different tools that I would use to do that. You guys have all seen these little solder suckers. They're a Radio Shack thing. You heat up a leg and you squeeze it, and it sucks out the molten solder. And those are pretty good. They're clunky, they're manual. Probably a better option to get to, for example, when you replace capacitors, is a desoldering gun. This is I would call it a low-end model. These are $150, that neighborhood for a kit. Reliability is okay. All of my tools are hobby grade because I don't have pro grade gear because it's very expensive. The jump between hobby grade and pro grade is quite significant. But as we were talking earlier, we were talking about, there's good and then there's cheap. A lot of the cheap stuff is poorly made in China with poor quality controls. This is a good example of that. This has shortcomings. It clogs easily. It's cumbersome to clean and replace. But it uses a mechanism. It heats the tip, and you actually slip the soldering tip over the pin on the backside, and you'll squeeze the trigger, and it sucks up the solder.
Okay.
But it requires a lot more maintenance and upkeep than a $400 or $500 Hacko version would. So this is not by any means pro gear. This is what you can get on Amazon type of stuff. More common for that. So that's my primary thing to get through-hole equipment or through-hole capacitors removed from a board would be the desoldering gun. There's also desoldering wick, which is uses a copper and has a flux built into it, and it kind of has that. So I put that on here. It's a braid, and there's one thing about molten solder and copper; they love each other. So you apply heat, and it literally will just pull as much as possible. However, there's a big problem. We're dealing with boards that are made 25 to 35 years ago. I'm working on a Commodore 128 that solder was probably put on in 1985 or 84, and it's very stubborn solder. So even with it being stubborn solder, there are some things that you can do to help the solder flow. It doesn't want to flow on its own because of oxidization. So you sometimes have to encourage it by mixing in fresh solder into it. That's one technique. Particularly when it doesn't want to come up. Like this will remove 60 or 70% of it, but that 30% will hold on to the legs of those RAM chips you're working on, or so that's where things like the solder brake comes in handy. If I've got a really stubborn one, I'll be working with the hot air gun. This can dump hot air through the nozzle, temperature controlled. I'll talk about this station. This is also a hobby grade station. The one thing about all this stuff is don't get your Harbor Freight, your Home Depot stuff. That's not going to cut it.
That's not even hobby grade.
No, it's below hobby grade. That's what's meant for people who are
Recreational.
Yeah, I mean this is recreational level as a hobby, but somebody who's doing pipe fitting is going to use a fat 60-watt Weller that has a fixed output, whereas all of these have different temperature controls. The desoldering station, the air gun, the actual soldering tool itself. So there's a lot of things you have to do to kind of coax these old solders to flow and be able to get the parts out. They don't want to come out on their own often. The newer the board is, like my Amiga 4000, it gives parts back to me much more efficiently than this was pretty good. The 68000 came off of it pretty easy. No damage to the actual parts of it. There's some things you got to watch out for. These little ringlets right here. These ringlets are where the pins come through. If they get damaged in any way, and it's very possible because of heat, they separate from the epoxy. If they get too much heat soaked into them, they're going to lift out, and they will certainly lift out if there's mechanical force applied. So they came out pretty good with no damage. It's just a matter of, and you could even see this was like one solid glob of corrosion at one point. So this has all been cleaned off and exposed the traces. Before I put the chips back on, I'm going to have to apply a coating on top of this. And that coating could be something as simple as a good quality clear acrylic nail polish for a hobbyist, or you can actually get proper solder mask in a liquid form that takes that UV cures, and that's the more effective and efficient way to actually do it is with.
That would also handle higher heats, wouldn't it?
Much higher heats. It's designed to take the heats, whereas something like a nail polish acrylic is, it very likely will melt and goo and probably crystallize. So
but you need to coat it with something.
You need to coat, because bare copper is worse. I mean, the copper itself was corroded when the battery leaked, and the leakage travels along and under the solder mask. Because you can see these traces are covered by solder mask. And I've had to strip off the solder mask in order to get the corrosion out of them. And when this board first came on my desk, it was a hot mess. Some of it went through the copper itself, and you can see we're down to the bare PCB. Yeah, and that bare PCB is.
And that's just the top layer.
Yeah, well,
That's the top layer.
it is a top layer of the actual FR4 material that the PCB is made out of. So yeah, and you have to be careful because this is what's keeping you from your ground plane. Now, luckily, this is your ground plane on this part, but modern boards have a ground plane and a voltage plane in between them. So you might see in a 5-6 layer board setup where you have the voltages are traveling across each other. So it's possible to create a short to ground scenario simply by compromising the material that's actually protecting the two of them.
There's a beard or an eyelash there.
It might be a cat hair, could be an eyelash, could be my hair. I don't know. Could be a cotton bud hair from when I'm cleaning them.
Yeah.
No, that looks like my hair. So it looks.
I got gray hair too. So I mean, our gear is just a little bit older than we are. So getting through holes out is often a challenge, and I'm going to show how I use the desoldering station to actually do that. And I'll start by trying to do a capacitor, but I need my glasses because I can't see beans. Let me find something on here that would work as a good, I guess, piece. Here's a 16 volt, 47 microfarad piece. This capacitor. He's all by himself. He should be easy to find. The one thing that's tricky, believe it or not, is when you're doing through hole and you got a board this big, it's often hard to figure out where on the other side of your board is the actual the legs for it. Yeah. So
you don't release the wrong thing.
Exactly. And you know what? I'm guilty of doing it. So because I know I'm going to screw this up, if I don't, I'll just run a Sharpie on it, and I know that X marks the spot right here. So that's where I'm going to be going. Is that spot right here? These two.
You can double check it because it runs at the end of that socket plane.
Correct. Oh, I should talk to you real quick. Personally, I found one thing worked really well. I didn't really set up for it here, but I put consumables on the left and tools on the right. And I'm not always squared up on that because you start getting more tools out, and then next thing you know, you've got a pile of tools. But tools on the right. I'm a right-handed person. Consumables on the left. I try and stay organized like that. Consumables being solder, wick, that sort of thing. One thing I'll talk about is this chip quick stuff. This is SMT flux. Flux is actually the magic sauce to soldering of any kind, and particularly with this old stuff. Now, you can get the brown goop stuff that you used to be able to buy at Radio Shack or Fry's. That's fine if you're doing onesie twosies. It leaves a ton of residue. They might say no clean on them. There's no solder or flux that is no clean. It just means it leaves no residue that causes oxidization. That's what it's trying to tell you. You can leave it there, but the residue is not supposed to trigger oxidization. And there's actually scales of how much residue of the flux is actually left, what it's intended for. Now, this is through-hole stuff, but I'm using an SMT flux. Part of the reason I do this is because this stuff is awesome. It is far better than the brown goop that we used when we were building our heat kits and our hobby electronics 25, 30 years ago. And I recommend this because it has a better heat transfer, and the whole idea behind flux is it acts as a facilitator for the thermal transfer.
Is this an online item?
You can get this at Fry's, but Amazon, Jerry looked it up earlier and I was talking about it. Obviously, I don't have very much left, but this goes a really long way. This is lasting me like 3 months, and I'm soldering like every other day. Sometimes doing a lot of desoldering, but I love this. Personally, that's my preferred flux. And one thing, let me obviously get the workstation up. I'm going to be a mess with cables. You guys will forgive me on that. Is I always will flux it first, and then try and flow some fresh solder into whatever it is that I'm removing.
Just loosen it up.
You know what? In all honesty, if I had more pro gear, this would be less of a necessity. So that's
Pro gear replacing the capability of some of this stuff.
Yeah, pro gear. I mean, you still need flux, but your heat transfer on the desoldering station is going to be faster. It's going to be more efficient, and it's going to pull even the older solder. It's going to break through a lot of that. So. At some point, I want to upgrade, and I think I'm going to drop $350 on a new desoldering station and replace this because I told you this is has maintenance issues. It'll put you in downtime where you have to kind of disassemble it and kind of clean it up. Yep. So kind of a problem. Our other part I'll talk about real quick is there's essentially two main types of solder tips that you'd want. There's the kind more the chisel style that have like a flat chisel-like edge. Those are really good for transferring heat because they usually have a larger tip that's coated with the tinning, the silvery part of your tip. Usually more surface area is that. And then you have the more pencil type where you have a very sharp point. And pencil types are good for surface mount. Because you need to get to a very small point and you need to drive a lot of heat into a very small point. But when you're dealing with through-hole or you're dealing with larger pads, a flat tip and a chisel. Now this is actually kind of a hybrid, and I'll see if I'll put this on the scope real quick so you guys can see it. This is kind of a hybrid tip. It's small, but it also has a bevel to it.
Yeah.
So there's good thermal transfer right there. I know that that's slightly out of focus, but
Well, it'd be better if you were down on the board, but
yeah, I can't-
don't touch
I
the
don't want to
board.
get too close to it.
Yeah.
It's not mine.
we can see it.
All right, but this is a pretty good one, particularly when it comes to through hole, because you can throttle your approach to the how you do the actual how you're going to flow it to the pin. You can actually touch the pin with one side of that edge and then flow solder from the other side. And the idea isn't so much that you want to jam solder onto the tip of your soldering iron. It's that you want to heat the part that you want the solder to flow to enough that when the lead goes molten, when we say lead, the solder goes molten, it flows to the metal, to the heat, it's drawn to that. And the flux helps facilitate that transfer. Yeah. So
How do you keep from burning your braid fingers?
I usually don't have that issue. Though I burn myself a lot with the soldering. I mean, that's inevitable. But generally, you're far away from it. I probably mention real quick. You guys know there's lead-free solder and there's lead solder. And lead solder has a lower melt point. It's a little bit better from a thermal coefficient perspective. It has better flow properties at lower temperatures.
But you want to breathe that stuff in all the time.
Well, so that's kind of a debatable whether or not the lead turns into an atomized particle that you would actually be able to breathe. But when you see smoke, it's often the flux that's making smoke, not the lead itself. And whether it's carrying lead, I'll know in about 20 years when I'm on a respirator.
Oh, good.
So anyways,
Part
I'm going to
two.
dump a little bit of heat on this. I can see where, get enough to soak it in.
I see smoke.
And my temperature is a little bit low for this, so let me drive it up. Another thing I should talk about is temperature as well. This is warming up a little bit more. The older solder stuff, the older boards when you're working on them, you do need to dump a little bit more heat into than working with surface mount. Surface mount, I might be doing 270, 280 degrees Celsius. I don't know what that is in Fahrenheit. For the older lead stuff, that's the through hole, that tends to need a bit more heat. I might go as high as 350 for 350 Celsius for doing. But the trick is to minimize your dwell time. Dwell time is how long you're making contact with the component. You also have to weigh out what the component is. If it's a capacitor that you're removing, you really don't care about whether or not you're dumping too much heat in. You're more worried about damaging the board itself. So that's, I might use a higher 350 temperature for the removal process, but for reapplication, I might drop it down to 310, 320. Ground planes, however, and a capacitor, these capacitors that we're replacing today are actually polarized. So there's one side is going to be a negative and it's always going to be on the ground plane. One side is going to be positive and it's going to probably have a thinner trace to it. The ground plane soaks up and sucks up a lot of that thermal energy. And what you're dumping into it, heat-wise, is going to be dissipated very rapidly. So I'm gonna, now that I got my temperature up, hopefully a little bit more. All right.
Was that board made in 1985 or 86?
I have no idea.
I gave you a general idea on
So I'm trying to find where the pin actually, or where the part comes out. This is the ground plane right here, so it's needing a little bit more heat. I'm just flowing fresh solder into it. You want to always keep your tip clean. A couple things about soldering. Old schoolers prefer the sponge, the wet sponge thing, and that's good. It actually does the least amount of damage to your tip, but this does very minimal amount of damage to your tip and does a better job cleaning.
What, Brillo?
It's not Brillo. In fact, you don't want to use Brillo because Brillo will actually tarnish. You'll get oxidization within minutes if you use on your tip, your soldering tip. You'll actually ruin the plating on that. So this is actually copper, which is not going to create that oxidization. So you can tap it a few times just to get most of the solder clear. But I always use the wet sponge kind of at the end of the day type of thing. Get ready to shut down. I do a nice fine clean. It's gentle. You're not jamming. Your idea is that you're trying to make the tips last a long time, and they should last for years. At the rate I'm doing, probably 6 months to a year is a good life expectancy as long as I'm doing proper care for it. The other proper care aspect is don't let it sit hot for too long either. Make sure that you shut down your station when not in use, because as that heat builds up, that'll start reducing the life of the tinning that's built into it. You can also do some retinning there. I don't have it with me, but I've got a little metal material. It's in a can. I got it from Radio Shack like 10 years ago, and it's still there. Plenty of it left. I probably will have it when I die. But occasionally you want to use that, but that shortens the life of your tip too, believe it or not, because you're actually putting contaminants onto the tip when you do that. So it'll get you a nice silvery tip, but it does also add contaminants. Yeah. And there might be better quality ones. Again, I talked about hobby versus pro stuff. There might be better options out there.
Actually, some of the pro stations that we have, we just replace tips every couple of months anyway.
Yeah, you're in a work environment or production environment, and that's totally different than me hitting for an hour or two after I come home from work and my wife and kids are down.
Yeah.
All right,
multiple Japanese technicians working all day long.
This is the solder. Now, as good as these are, even at the pro ones, you do want to make sure your channel is clear. And they all come with a little bit of a. That helps. Once I get a good flow like that, that lets me know that the channel all the way to the back here. I did some work with this last night, so it might be nothing. As you squeeze the trigger, the vacuum comes on. Now, you want to transfer the heat first. Wiggle it around and get enough of that heat transfer before you start the vacuum. And then when you
the wet vacuum.
Yeah, and then when you pull the vacuum, one thing you want to do, at least with the hobby grade ones, is you want to keep sucking as you pull it away, because you don't want molten solder getting stuck in here.
And drain it back out.
Well, not just drain it back, it clogs up, and because
where it gets cold.
Yeah, it gets cold enough to re-solidify, and next thing you know, you're looking at having to drill it out or do apply heat from the other side, hold disassembly.
A lot of work.
It is a lot of work, but again, a pro workstation is going to do this. Need maintenance far less than the hobby grade ones. I'm going to be holding it vertically. Ideally, I like to hold it at a right angle because it's not fighting gravity as much.
Do you use a board stand to hold it up?
No, I need a board stand. If you got one, let me let me know. I definitely need one,
okay, because
these are very awkward to work with, and
especially the big ones.
Especially the big ones. But even I've got a 128 board, which is about here to here, and there are times where I need to work on both sides of it. And I'm using getting my chin in the game. Yes, to hold in a totally bad scenario here, but you make do with what you have. So the thing is you want to get the leg of the capacitor through that hole and then wiggle it around a little bit, let that heat transfer. Remember, the ground planes need longer time to do that, and then pull it out. Okay, so we're going to do that real quick. I can see the leg for this is pointing slightly that way, so I'm going to have to come. Okay, I'm getting heat transfer. This is the ground plane. All right. So we actually did a little damage there. We might have dwelled too long. There's a bit, some of the solder mask is actually removed around that, but there's going to be enough area there that I will be able to re-expose it with fresh solder and it'll close up. So maybe try to do this a little bit less. All right. No,
You can actually see that melt.
Yeah, you see it, you feel it also. You feel the leg float around. I don't think we got a good one on that one, but right now the solder, remember the solder's going all the way through the board, so some of it may still be clinging to the legs, right? So sometimes you get really good, and depending on the age of the solder, but I'll use the solder, actual solder iron to help loosen it out a little bit. Yep. And the ground plane is a little bit tricky.
In some of the capacitors, we discovered that if they're cut long enough, you can actually heat the leg longer to get all the way through.
Yep, you're right.
And that's what a lot of hobbyists do. did a long time ago. Is just
No,
leave the
they
legs-
cut too short.
Yeah, leave them a little longer than normal. That way they can get access to it.
So I got a stubborn leg. I'm just going to give it a little bit more flux to help facilitate heat transfer. Now, if it doesn't give, I'm not going to try and force it mechanically because that's where you are going to create damage.
You don't want to force.
But I can reapply fresh solder because now I've got a more contemporary, healthy solder. I can reflow that in there and then use the gun again, and that should remove any of the remaining stuff.
It's a lot more stable.
Yeah, it is a lot more stable. Let me try this first. Let me see if I can use, I just gave it a little flux. And what I want to do is I want to see that leg move and I want to see that leg give. Part of it might be that it was bent on assembly. So trying to get it centered up a little bit better. And then, you see both legs are moving? All right. Yeah. There. It's actually kinked. The metal.
The leg?
The pin is kinked. Yeah, that's the problem. There we go. Just need a little bit of love.
My uncle, my second uncle that I had, his son was into RC cars and everything.
We're desoldering
back then.
components from a
And
motherboard.
He had issues with solder back then too, and that was when I was in my teens.
All right, so I don't know if you can see this, but the legs.
Wow, that's a bent.
So they were fighting me from a mechanical
Damn.
perspective.
That's
No, this is very normal, but the legs were fighting me from a mechanical perspective because when they were
twisted.
yeah, when they were installed, when it was installed, I guess it was given a mechanical twist and bent. That's why this was struggling and it was holding on, had gaps in it that was keeping the solder from flowing really healthy through it. But that's so. Thing about replacing with capacitors, there are cheap capacitors that you can buy, and there are high quality ones. When replacing capacitors on vintage equipment, you want ones that are going to still be around 30 years from now. You want the other
High
stuff
quality.
to die first. So higher quality, not necessarily high quality, but you look at their mean time between failures, the data that's on the spec sheets for the capacitors, and use that as a guide. And something between 2,000 to 8,000 hours is good for a standard electrolytic capacitor. However, newer technologies such as polymer capacitors don't ever leak. Everything else will be disintegrating around it. The capacitor should still be viable. But there's, again, a price that you pay for that. There's a cost aspect of it.
Well, one of the questions is how long do you expect your recap motherboard to go again?
About 25, 30 years, but if you're buying, quality Nichicon or Panasonic branded parts, as opposed to the cheap stuff you might pick up in the bins at Fry's or online, you're probably going to get better life out of them because there's more manufacturing data to back it up.
Do you really think the silicone won't dry up in another 20 years on the motherboards?
No, sure. The other issues. Usually, it's the passivation on the ICs that is the issue when it comes to
Longevity.
whether or not the board will be viable 30, 40 years from now. There's that school of thought that's basically of the mindset that in the failure curves for components, your first couple years, your first dozen or so years, you have very high infant mortality. That's when all of your manufacturing flaws start showing up. That's when, so usually within a dozen years, if it's still around after that,
It should last.
chances are good you're past the curve. This one is not going to be subject to infant mortality issues. Now you have just wear out as a potential. So something called the bathtub curve when it comes to failures. If you think about when something is new and made, appearing for the first time, your failure rates are typically much higher. And as your manufacturing processes mature, as your engineering quality, your QA gets better grip on identifying failures, the failure rates start to fall dramatically until they stabilize. That's the bottom of the bathtub, right? Now, along that bottom of the bathtub is where your chemistry is stable, your environment is stable. As long as a lot of things are constant, you don't introduce a lot of variables to it, you should have a really long, extended life out of whatever that component is, because you've survived the infant mortality period. As you get closer to a period where some of the polymers start breaking down, some of the chemistry starts breaking down. We talked about the integrated circuit passivation techniques. When the chemistry starts to wear down on those, then you start getting issues where it once again becomes an increase in failure rates. Does that make sense?
Yeah. Well, and we're seeing people who are trying to update or replace their motherboards or things on their motherboard, and certain things are breaking based on, for example, the plastic sockets will break.
Correct.
Or when you pull an old chip, it'll just crack or crumble.
Yep.
And so sometimes you wonder, is that happening to the motherboard as opposed to the chips and sockets?
You could wonder that, but FR4, which is a material that they make PCBs out of. It's also known as Garolite. Garolite is a distant cousin to Bakelite from the 1920s and 1930s. So that popular Bakelite material, which is one of the first consumer plastics, if you find Bakelite today, it's still very, very strong and durable if it was made properly. And if it was stored properly, it hasn't gone through a lot of deep thermal cycling. So FR4 doesn't have a lot of aging issues that we know of in our lifetime experience.
What about environmental considerations? One of the strangest things is people from certain parts of the world. For example, I have friends in Louisiana.
Mm-hmm.
They're very careful not to get their stuff wet because of rust and all those things.
Yes.
But you still see rust appearing inside cases and things, and corrosion.
That's galvanic action that's taking place when you're getting that kind of corrosion. So you're getting it from the atmosphere, you're getting it from the salts that are in the environment there. You're also getting it from ozone. Ozone is a natural, and when you have thunderstorms, rainstorms, you can smell ozone.
Yeah.
So ozone exposure, which is part of the atmosphere, encourages galvanic corrosion rapidly. So that's something else that may be a factor.
Well, it's like we see cars from flood areas in Florida end up in California because they clean them up and sell them. We're also seeing computers from that part of the world come here, and we end up cleaning them up.
If you can get them back, but if you can. I'm a Floridian, so my first car was a beach car. It was a 1967 Plymouth Valiant, right? Mm-hmm. And that car was rusted. Like you kick it, and rust just rained out of it. But nobody cared. That was kind of the normal because you didn't out here where it's much drier and far less salt in the air.
And no salt on the road.
Yeah, you're not dealing with salts in the road like you might find in the Northeast. Yeah, it's a totally different thing. So your corrosion levels way different.
I'm used to the lesser corrosion levels.
Right.
I'm a Southwest boy, and there was never any of that stuff.
That's why a lot of important stuff gets moved to the Southwest because of more stable humidity, more stable environment overall. Mm-hmm. Like you look at the
airplanes in the desert.
That's why they park at Pima. The military parks all of its.
The graveyard.
But you can go out there and get working parts because they're dry.
They're dry.
50-year-old B-52 or whatever. Mm-hmm. Yeah, they're there. So what I'm going to do is I'm going to replace this capacitor with, and I probably should have checked my kit, make sure I have one. So we're looking for at least 16 volts, a 47 microfarad, and you got to be very careful when you look at things like 47 or 22. Make sure there's not a period in front of it.
4.7?
Yeah, 0.47 or 4.7 or 47, which with our old eyes, they all kind of look the same, so you kind of have to do a really good, careful inspection.
And what does the UF stand for?
Microfarad. So the farad is a unit of measure for capacitance. Mm-hmm. You already know this. You're testing me, aren't you? So farad is a measure of capacitance for the capacitor to hold energy, and you can measure it in microfarads or picofarads depending on the scale.
If we're going to stream this or we're going to show it later, that kind of stuff helps.
I appreciate the shilling, but you will quote me. I'm a hobbyist. I'm not professional. I've never been trained in doing any of this. Okay. So I've got a capacitor. Oh, this is where my library, if you will. So we're looking for 0.47. Yeah, that's probably bad. 4.7. That's bad. 47 microfarad. So the trick will be finding one that has the right size. So these are 47 microfarad, and it looks like mechanically they look about the same. I don't know if you guys can see it. Mechanically they look about the same as the one that I was just working with. Some of these are higher voltage. Now, you can generally put higher voltage rating on your capacitors in replacing an existing capacitor. So So if your
But is it
capacitor
rated?
is 16 volts,
Could it be rated higher for the board?
it probably, whatever they installed at the factory would be the lowest you should find acceptable for its voltage rating. You don't see very large voltages in these systems like this.
No.
At least this part, I don't know where this is, what this component is. I just took it off randomly. But the physical size of it often is associated to the voltage of it. Let's see. We're looking at this one is
Wait,
that's
micro number.
I changed it.
That's a 40.
That was the temperature. This is a 47, 16 volts. Once again, so this is a like for like, but it's a smaller capacitor significantly.
Yeah, smaller.
So I think this is a no-name one. This is one of those ones that's like a generic.
Generic?
I wouldn't put this in an Amiga personally. I'm going to go find a Panasonic or a Nichicon or something of better quality than that. That's just Chang. I don't know what that is. But that might be fine for fixing the radio I found at Goodwill. So these are some, I don't know what brand these are, but this is 47 microfarads at 50 volts.
50.
And I'm gonna go with one of these. Physically, it's pretty much the same size. The one thing you do want to make consideration is the height as well as the diameter of the capacitor and where it's going. And that's more from a mechanical perspective than it is from a functional perspective.
And it's a real issue in some of the things that like Indivision made, because it doesn't fit over a particular capacitor. You have to
Right.
actually exchange them
Right.
for a smaller one or one that can go horizontally.
Right, or if there's like, an FCC RF shield that has to go over it, or like you said, interference from other cards, or like if there's capacitors underneath. So here's an example. I've got some Amiga 500s that are from the Abyss that I recently worked on, and I replaced several of the capacitors in them, doing a full refurb on a couple of them. And the RF shield that's on the 500 goes all the way to the back, and there's two pretty chunky large capacitors that are in the very back.
Yeah.
I think it's right where the disk drive port is, or maybe it's the 25-pin parallel, way in the back left. And if
Back right. This drive's on the right.
okay, well, no, this was for the external floppy. External floppy. So I'm thinking.
Left.
You know which one it is? Okay. So anyways, there's two capacitors back there on the Rev 5 board and Rev 7 board. And height matters in that case, because if you buy a normal capacitor that you're going to see listed from Mauser or DigiKey or one of those suppliers, most of the ones that are the first search results are going to be too tall for it. They may be great in applications elsewhere, but for that particular location, they interfere with the ability to actually close the FCC shield. So I'm going to steal this capacitor and put the rest away. And what we're going to do is we're going to get that guy into this is
You
all
also
very
want to
basic
make sure
electronic
that
stuff.
you got the direction where it's going into the
So
socket too.
Kenny just brought up a really good point, and that is, so capacitors come in polarized and non-polarized, depending on the application. Electrolytic capacitors are polarized. They have a negative side and a positive side. It is super important to make sure you get this right.
You don't want to boo-boo.
In fact, if you do make a boo-boo, which, and I'll actually talk about this when we talk about the 3640, because Commodore in their
Put 'em in backwards.
manufacturing wisdom, somebody loaded up the pick-and-place machine and didn't actually pay attention to polarity, and they put on 3 capacitors backwards. Now they don't explode.
No, they do.
Though they can explode, and when they explode, they basically blow their lids, and all the little paper guts come out, and looks like fibrous hair sticking out the top of it. But that's what happens when you dump voltage into it. The explosion stuff is more likely to happen in larger capacitors that are dealing with bigger loads.
Power supplies.
Yeah, I'm gonna turn off my desoldering gun because we're not needing it right now.
See, the thing is I learned this from my my other 2 uncles that I had, and the younger uncle that I had, he wasn't into hobbies because he felt like it was too boring.
not a hobby.
Yeah.
Well, he was a trucker. That
So-
was my uncle.
So LEDs are like this too. If you've ever done any kind of
Yeah.
LED type soldering or diode soldering,
Plug.
they tend to indicate the polarization based on the leg.
Leg.
Right. So the long one is usually your positive leg, and it's the same thing is true with LEDs. Like when you're soldering basic LEDs up, is that longer leg. Now these are polarized, and most of the ones that are subject to early death or causing the death of an unfinished computer is an electrolytic capacitor. There are other capacitor types that are called ceramics or multi-layer ceramics, MLCCs. Those are the discs things that we see, the brown discs on motherboards. On newer equipment, they'll be surface mount, and they'll look like little teeny Lego bricks. And so those are typically not polarized. Whereas the electrolytics are. Tantalums are also typically polarized. So let me feed this through. I'm going to find the hole. Let me switch over to the other camera and figure out where did I take this from. Okay. So I'll put this on here real quick, and we'll see if we can get a shot of it. So there's a circle here, and it's marked positive and negative. Now, there are times where it's not marked. And
Or marked incorrectly, like the 30.
or marked
like the-
incorrectly.
like
Well,
the
actually, they're
31st.
marked correctly on the board. They're installed incorrectly. Because when you measure the ground plane,
I thought the 3640s were, it actually is printed incorrectly as well as.
you might be right. I just know that I've long since fixed mine. So, but it was an issue because you actually can measure the ground plane, and you can. So when I say measure, you're using your multimeter and set it to continuity mode and buzz out to verify. So if I couldn't see that there was a plus mark here, I would set my multimeter to continuity mode so that it does a little beepy thing when you make
If you're positive or negative.
so that lets me know my continuity. Now chances are good that this one right here that's marked positive shouldn't be beeping when I touch the ground plane. And if it does beep, like it just did very briefly, that's because some other capacitors that are in this circuit have just enough charge to complete that circuit before it says, okay, you get no more. So it tricks it into thinking that there is true continuity. But if you're just getting it for a beep, just know that you may get an initial beep, but if you're not getting a sustained beep, that means that you're not seeing direct continuity. So this technique is how you troubleshoot circuit traces quite extensively. But it's good because if I put it here for the negative, it should, when I touch the ground plane, give me a nice solid beep like that, right? So that lets me know that I'm working, that I have the correct orientation. Now that's not entirely universally true. I'll put that disclaimer out because you might have separate power rails that are isolated from your main ground system. So there may be capacitors that aren't linked to your primary grounds. That's typically not the case in our old Commodore equipment. All right, so remember, longer leg goes in the positive, shorter leg goes in the negative. You know, I think I need to clean that.
The hole.
Yeah, the leg when I was removing it. I guess that's a good thing I can do right now. So there's a bit of solder still on the top of the board, so I'm going to quickly remove this. It's on my ground plane, of course, where the heat transfer was the worst. Going to use my solder braid, and I'll just quickly tap it with the solder braid and dump some heat onto it on the other side. And I know you guys can't see this, but you have to trust me.
I see smoke.
Well, this is the ground plane, like I said. Ground plane sucks up a ton of that heat.
It draws it further than just at the point.
Yep, it's pulling it away from where I want it to work.
It's another thing with these old boards here. That's why I think we need new machines.
At least they were generous.
Yeah, they were.
Yeah, there we go. So, just verified it's got a good hole
You can
all
wear
the
for a
way
long
through
time
now.
and still work.
Yeah. Well, that's what's so good about IBM when they did the boards back then. They did their.
That's just the technology back then. It's
on the
better
boards.
now.
No, the
Oh,
boards-
Kenny, it's better now. Let me tell you.
Well, I know that, but I'm just telling you what the IBM system people did when they said.
They cried.
Yeah.
They used to cry.
Okay, what I'm doing right now is
We wanted
shaping the
to leave them
legs
their way.
to make sure that I get enough space on as I'm putting them in there. So let's try feeding some. That, and I kind of bent it up when I was mechanically forcing it into the hole. Yeah, that's better. So I don't know if you guys can see that. It's physically, it's in there good enough.
Is it in deep enough? Because remember, you
Yeah.
have height.
So that's the thing. So there's a couple of schools of thought on that. I want to point that out. Some people like to have very flush mounted to the PCB, but when you do that, you notice that the factory ones, these are all like tipped over and bent, and makes it so they're easier to move out of the way. But at the same time, this also creates potential for break. So you're kind of choosing: do you want something more mechanically stable, or do you want something that has some give to it so that you can push it out of the way when you need to? Like you're fitting in a card, and that card physically interferes with the capacitor. You want to be able to push the capacitor aside
Just a little bit.
just a little. Yeah, I mean, you can see this one's bent like almost 90 degrees, and
I always wonder why they didn't make one with legs that were set up that way.
I don't know either, but I like to do mine flush, so I usually pull them from the other side
As much as you can.
as much as possible. Yeah. So I know, Brian, you're not going to see this, but I'm gonna, while I'm holding it from one side, I'm bending the legs just kind of at a 90-degree angle,
Then give some tension.
just to apply some tension. And mechanically, it's got a little bit of gap in it, which will allow me to play with it, but not as much as this guy over here that's laying down on the job. It really doesn't matter. The one thing is that if you're working with them, the idea is that, especially on a board as awkward as this without a board holder, you just having it secure itself while you're soldering gives you a little bit more flexibility from your work point of view.
And actually, they used to train when we put chips and stuff on was to bend back all the chips to one side to give all the legs to give tension.
Right.
So you could then just touch and go.
And from a desoldering perspective, it's a pain in the ass.
But to put them in,
To put them in, you're like it's no problem. But it's like when I'm doing an IC. So like you're talking about, the legs are bent either outward or inward, right? I'll have to kind of, as I'm preparing it for desoldering, I will heat them and bend them up if possible, just to facilitate this guy. So when he's going on it, it captures the leg better, and I can get a better flow out of it.
and then the secondary mechanical thing is at the end of all this, you got to cut it so it doesn't touch even go or force some 4,000 boards actually push through the plastic. They were so sharp that they actually pushed through the motherboard plastic thing to keep it from touching the
Yikes! Yeah, well, we're trying to avoid doing any more damage than these things have already had.
And you know why people did that? Because when we pushed down the accelerator cards, we would constantly push really hard to get the accelerator card in, and it would push the points
Right.
through the plastic.
Wow. Yeah, that would be bad.
We some of us actually put in little rubber bumpers so they
Right.
would spring back.
To give it some recovery.
Yeah, so it wouldn't touch.
So I'm putting a little of this SMT flux just down here on it, and my goal is to flow a little bit of solder right there. Now, thing about putting solder on there, number one, a quality solder station helps significantly. You don't want to do this with that, the Harbor Freight special you got. What your goal is with through hole is to create a fillet of solder that kind of looks like a ramp or a tent almost. And the idea is that from the board surface to the pin, you want just enough of that fillet. If you build it so it's a blob or a chunk or whatever, you've got way too much solder. And plus, keep in mind that solder is also flowing in through the board itself to the other side. And if you dump too much solder in, you actually will create a more unstable thing because you'll have solder caked up on both sides.
I call it a pyramid.
Yeah, that's kind of what we're after, Kenny. It's kind of a small pyramid of. So again, I'm touching the legs and the board at the same time to facilitate that initial heat. minimize my dwell, and then give it some solder. Do that again over here. So one thing that's a problem when you do this is it is messy. By messy, I mean that you create not spillage, but it's messy because the flux, once it starts heating up, it changes. It turns into a goopier substance. It gets brown because it's capturing a lot of the contaminants that are present, and you have to remove it. You shouldn't just leave it there. But it's not uncommon for us to open up a Commodore 64 and find, a nice board, and then there's like somewhere over by one of the connectors, somebody at the factory, typically, that was the last thing that they did, and it was something that was done manually by hand by individuals, and they often had nasty flux residue still there after 35 years. So you want to clean it up because somebody's going to be seeing this at some point, and you want that flux not to be in their way, and it's also good practice because flux does change chemically over time too, to where it starts actually acting as an oxidizing agent. All right, so
that is, nobody actually talks about that end of it. How do you clean that?
So I'm actually going to talk about that. So let me show what I've got first. Let me see if I can put this onto the microscope. All right, that's terrible looking, but it's serviceable. See if I can get this. See what I mean? All that goopy stuff. We're gonna have to get rid of that.
Good folk.
That black stuff.
The black stuff
is just that. You know what that black stuff is?
Runoff.
My Sharpie. So, got to get rid of that too. So, a lot of people who work on this like to use what they call isopropyl alcohol, but it's not the kind of stuff you get at Walgreens. It's a higher percentage, about 50-60% concentrate or higher. The problem with that stuff is that unless you start getting into the commercial grade stuff, the industrial grade stuff, it's got contaminants in it because some of that is actually water. You need to be able to have it so that you remove it and it doesn't leave a residue. And if you use like your Walgreens isopropyl alcohol, it's probably going to leave more residue after you. And you'll be constantly fighting it to clean it up.
It's only 3%.
whatever the actual percentage is. So I use my preference is denatured alcohol. I've loved this stuff. My grandfather used to use it, and he was a TV repairman. I found out that denatured alcohol, which isn't much different than IPA, it's just got a bad taste to it. If you know about the story about Prohibition and why denatured is present in America and probably not as prevalent overseas, but I find it leaves less residue. That's a personal preference thing. Most people talk about using IPA as a way for cleaning up this kind of work. I'm going to do this, but first I'm going to trim the legs, and then I'm probably going to look at reflowing the solder that's right there right now. So you want a good flush cutter. I've got a decent one. I need my glasses because I'm getting old. And these are actually like meant to be focused at like this distance. So when I went to the doctors, I said I work with things that are sometimes inches from my face.
Pretty strong leg.
The trim around the leg itself.
I was going very gentle on it.
As you should. Cutting the different sides each time. You're supposed to just cut it snipping through.
Some people say these things. I think it all. To me, that's a short waiting to happen. The legs.
Yeah.
Now, personally, I know that this is good enough right now.
Mm-hmm.
But personally, I always tap it with the soldering iron one last time after I've trimmed the legs, and that will help create a better fillet of that solder to the leg after I've trimmed it. Because if I've trimmed it and I've kind of lopped it off so it's like a mesa, I might have it so that it's got a fillet, but the mesa part, by trimming and then reflowing it, I'll carry it all the way to the top of the pin. It'll actually create a little bit more aesthetically pleasing joint. So I'll hit some more flux. And then
I like microscopes.
yeah.
Oh, that's not much. That's cool.
It's a little better.
You can see the goop come from the flux.
Yeah, you saw it spread out too, even.
That was pretty good.
Yeah.
We're not going for awesome, we're going for functional though, because if you get really down to it, you will spend a lot of time chasing awesome. When this stuff hides in the bottom of a board, there'll probably be other problems before this is ever an issue. So got to get it up. Acid brushes are good. These are kind you might get welders style acid brushes. This one's seen better days, so it leaves hairs behind often. I've trimmed it a bunch of times. But this is good for using the IPA, or excuse me, the denatured alcohol and forcing it in. Toothbrush is good. The one thing though is remember you're displacing when you're cleaning with a brush. You need to actually remove. So you can use chem wipes, tech wipes. Those are what you might find on a pro workstation. I got paper towels because I'm, again, hobby. But I will tear off a small piece of paper towel, and I found that it's really good for through holes. Though through hole wants to snag everything. The little legs want to snag everything, so it's better to blot. Now I never once talked about this, but I've got no way of grounding myself here. Whenever I do this at home, I'm fully grounded. This is a wrist strap. I have it's got.
So you're grounded to whatever you've got.
No, I'm grounded.
No.
I'm grounded to my house mains.
Yeah.
And that reduces the risk of electrostatic discharge, which can kill this type of equipment. Now I'm really taking a gamble here because I got a lot of dissimilar materials. All of them are being interacted with. I'm building up a charger. We're on carpet. A lot of bad things could happen. I'm hoping that's not the case, but it is a risk.
Since your body is, your leg is attached to the.
It's not sufficient. No, it's not sufficient. It's carpet. It's about different materials.
Also, he's got rubber soles.
Yep. So like, I have an ESD code that's part of my work and stuff.
Oh, look at dissolve the ink.
So yeah, it's nice. It's kind of retro looking itself, isn't it?
Yeah.
So we're just trying to mix in that IPA and force it around the area that we're working on, and we're trying to force the flux out so that we can get it captured in the liquid, and then from the liquid we're going to blot that up. So it's not uncommon. I will dump a lot of IPA or denatured alcohol directly onto a board to wash and irrigate. Electronically, it's perfect. It's a really good substance. I don't know if
Dishwashers are good too.
I'm sorry?
Dishwashers.
I've heard people, I wouldn't put dishwashers because it uses city water and
City water.
you get calcium deposits, so you'd have to do with the dishwasher. People have done it. There are people that will clean keyboards especially. Put your whole Commodore 64 keyboard in there. I've never done that, and I'm not going to be honest with you, because I don't trust the solvents that are in.
I don't even trust the well water either.
So there we go. I mean,
Especially the well water.
That's pretty much it for replacing a capacitor. Once you've cleaned it, inspect your work, make sure everything's
It looks
good.
okay on the front side.
Another good thing is Q-tips. Q-tips are really good for just everyday Q-tips. The thing is, you have to be very careful. These want to dump fibers and snag on everything.
Mm-hmm.
There's a trick to it, though. It's to actually spin the Q-tip, kind of create like a little vortex as you're moving it around.
Go
to,
with the flow.
To help keep all the hairs
Twisted around the stick.
twisted around this, so it keeps it from dropping hairs all over.
You go with the flow where the cotton was wound on the stool.
Well, it's not. It's more. You're going to make it wind essentially.
Yeah, you're winding it, dude.
Totally haphazard here. Let's see if we get here. All right. So there's still residue. There's flux that I applied afterwards. What we're going to do is clean that. So I'm going to dump a little bit more denatured alcohol around it. I'll get around the whole area too, because I'm sure there's other crud waiting to happen.
I love microscopes. That's what they're for.
Well, this is a cheapy USB one.
Your tip is saturated now. You need
Flip it over.
You know what? It's okay if it's saturated. The idea is that we're picking up the contaminants
right.
from the flux. When denatured alcohol dries, and this is why I like it better than isopropyl, is it doesn't leave as much residue.
Mm-hmm.
Right.
And you can see as it dries, you can see the residue lifting.
Yep.
Clear it out.
Yep.
That's, again.
So literally, I've dumped on boards like this because this was really nasty. This is after I cleaned it.
Came out of Florida, right?
It came out of Florida, came out of a guy's computer that's been there in storage for 20 years.
Wow.
Tons of crud. Tons of crud. I want to see if I can get it back and running. I said, send me the board. Tons of crud on it, but other tools besides the acid brush, cheap Harbor Freighter, Ace hardware. Now, some people will sell you ESD ones. It's just nylon, okay? That's all you want. Nylon brushes. Go to the dentist, get a free toothbrush. I have an electric toothbrush, so I don't need it. So, there you go. Scrub away. And I will irrigate the snot out of this thing. I'll lay it in a bed of paper towels, and I'll stir it at the top, and I'll let it just keep flowing down in the same direction and collect at the bottom. And I'll just keep working my way down. It's like, it might be 2 or 3 hours spent just cleaning. But that's part of the process for the rehab and restoration.
If they're clean before you start pulling stuff, then you got less to move.
Yeah, you're not wasting your time with that. I mean, so I'm scaling. I'm trying to think, how would I want to return this board to service from me? So I would want one as close to, as best as I can get it back to factory fresh. I mean, by no means, I'm not a purist that it has to be like original things. I have no problems with.
And even from the factory, they came with residue on them.
In some cases, yeah. Particularly around connectors, because I think, a lot of the boards were done through automation, reflow ovens. They have, there were wave soldering techniques that were common in the 70s and 80s. There's parts that they put on through automation, but there are parts they had to put on through some dude or a gal sitting inside of a soldering station, churning through hundreds and hundreds of these a day, and that was what she was paid to do. So we're done. Always do good inspection. I mean, I look very closely at everything, make sure I'm happy with the solder joint. We were talking a little bit ago about how you were working on a Pi 1541 hat you built, and your son called you out on some cold solder joints.
Yep.
Yeah, but you don't know this because you got to look at it very closely to recognize that. And cold solder joints are usually instead of it being a nice, shiny, smooth fillet on whatever it is you're working on, instead you're getting slightly off-color, less silvery looking pits in it, a duller color. Chances are good that you either reflow the solder by dump some flux onto it and then reflow the solder. That does fix a lot of cold solder joints that are fresh, but it's probably better to just start it over in some cases if it's been 30 years of cold solder joint.
Well, the other thing, of course, is that in your case, you're doing this. You said a couple hours a day in this, probably. For now, I haven't picked up a solder pencil in 5 years.
Right.
And so it takes your memory, muscle memory's there, but you have to. If you haven't done, you have to practice.
You're right. And this is by no means like none of what I'm doing is a definitive. This is how you do it. How you do it is based on what techniques you found work for you, depending on what you're working with, what equipment you have, what skills you have and techniques. Just understanding that your goal is not to damage something. That's the first and foremost goal.
First, do no harm.
Do no harm, right?
That sounds like the doctor's.
Yeah, exactly. So first, do no harm, but also you want to restore it to functional state. And I'll sidebar real quick. Down in Florida, there's a guy who does aircraft restorations. He's super rich, inherited his money. Parents discovered oil in Australia. Okay, so
Trevor.
Huh? I guess maybe Trevor-ish, but Australia in that case. Wherever.
I'm teasing you.
Super rich. So he basically has a huge chunk of land and has about 100 vintage aircraft, pre-World War II, all the way up to Vietnam era. Even public transportation, military, all of that. He's got an enormous collection. 1920s era racers, all that stuff. And his goal is to have everyone always available to fly whenever he wants to fly one. And to achieve that goal, he's got. Last time I was in his warehouse, he had like 18 Merlin engines for P-51 Mustangs still in the factory boxes. And he'll sell you one, but you have to promise you're not going to put it in an airboat or a monster truck. It has to be going in the P-51D Mustang. But his philosophy, and he's been beat up by people who are like Smithsonian types, who are like, oh no, this should be in a museum. you shouldn't be running it, you shouldn't be flying, you shouldn't be risking it. But his mindset is no, these were built to fly, they want to fly. And the only way that they're going to stay good is if I keep them flight worthy and ready. So these computers can be thought of the same way too. You can either buy it, collect it, put it in a shelf and never touch it, or your goal should be, I'm going to buy it once in a while, I'm going to collect it, touch it, I'm going to drive it. And whether it's for nostalgia or for just to make sure it works, or find out if you got any more things you have to do. So anyways, we're done with this from a capacitor replacement. Are there any questions before I move on to SMT real quick?
Just a general question from Bill Gideon here. This hobby grade setup would probably be what, $400 or $500?
Yeah, I think we're looking to about $400 or $500 is probably a good starting point. Believe it or not, you spend a lot on consumables, good quality solder.
Sure.
The fluxes they mentioned, might be $20 a tube. Optics, dust extraction. I mean, to give you an idea how budget and how hobby grade this is a baking mat. It's not a fancy pants ESD safe solder pad. I mean, I do have one, but this is my preferred one because I can dump heat onto it and it won't change its shape. It's a silicone mat, and it's the same material that you do other solder work with. And this is like $12 on Amazon. So, and it makes for a colorful, attractive work surface. Provides a lot of good color contrast.
Also gives you contrast.
Lots of good color contrast, yeah, especially for this. Normally I use that gray job right there, which is a bit thicker and a little bit more pricey, but has magnetic things to hold
In place.
stuff, yeah. But yeah, $400 or $500 is a good starting point. This is about $150. This is about $150, $200. Those are your core items. Learning the skills. So for learning stuff, there's a lot of good YouTube resources out nowadays that weren't available, from everything from micro soldering, repairing iPads and iPhones, to vintage tubes and big iron hardware. There's plenty of good references and resources and skills from hobbyists to people who are professionals in that spectrum. So anybody can learn this as long as your blood pressure's in check well enough that you can not shaking as you're going at it. You probably have a good chance of being pretty good at this. Being able to see as augmented. I've got this. This is for you guys have seen me wear this at the show, and
Magnification.
this is significant magnification. The scope is a good tool because it lets me work at a pretty fine level, but it's not as real time. You can see it's off by 20 milliseconds,
20 milliseconds,
something like that. But it's not a great quality scope. It was intended for kids to play with bugs and stuff, not necessarily people trying to do electronic repair, but it's functional. The next step up is a $500 or $600 scope. I mean, that's the jump from a $70 scope to a $500 or $600 scope for one that's built for electronics works, where you have a big stage and has good optics and $400 or $500 more for the camera option to plug it into your computer and record. So, any other questions? So somewhere around 1990, when the 3000 came out, manufacturing processes. Was it 1990 or 89? Michael knows better than I would. There was a change in Commodore's manufacturing processes. They went from the traditional through-hole stuff, which was prevalent from early 1970s all the way through to the mid to late 80s. But then around 1990, a lot of manufacturing transitioned over to almost entirely SMD or SMT work, surface mount technology, which isn't through-hole intensive. It relies on components essentially being bonded to the board instead of mechanically bonded through it, and hence the term surface mount. So this is a 3640 right here from an Amiga 4000. This is actually a dead board. And I have no chance of reviving this because not without significant work. The ground plate is shorted. Part of it was because of bad capacitors. This sat without capacitor replacement for a good 25 years. And when I finally took it out, I said, I want to see if this, was my spare 3640. I want to see if this still works. And didn't do buck kiss. My 4000 wouldn't boot. Worked fine on my other 3640. So when I took it out, I'm like, okay, well, this one has the capacitor bug, which, I said, okay, I can fix that. That's not a problem. Remove the capacitors. Well, the problem is it was still shorted to ground. Well, it was shorted to ground because several capacitors had essentially spilled their electrolytic compounds, and it caused corrosion, which that corrosion goes through the metal, it goes through the plastics too.
To the other side.
It doesn't really so much eat the FR4, but it penetrates in between and compromises it. So you've got essentially a short to ground scenario on this board, which I may never be able to find. I've tried. I think it's got like a 22 ohms resistance across it, no matter where I check, which lets me know that whatever it is, it's probably a 22 ohm
It could
resistor.
spread the entire length of the
Well,
film.
once it's short to ground, it doesn't
It
matter.
just-
I
shorts
probably
down
would need.
altogether.
I would probably need to dump voltage into it, find out where it is thermally going hotter to figure out where my short is, but I would probably lose. There might be other ways to do this, but it's not economically viable to try and revive
But
it.
at least
Because
you have components that you can salvage and
I
take
do,
off.
I do. There's good components. The reason why it's not economically viable is because guys like Paul and John Hertel have put together, this is a Chucky Gang 3660 board, and these guys have reverse engineered this, made this, so that guys like us, that Paul's done the A4000 board.
4000 board.
He wants to do a 2000. The 500 board has recently been done, and the 1200 board has recently been done. So basically, all of this old gear, all these old boards, have been redone. The next up, and Paul wants to do it, I think, and I know Chucky's working on one. He's doing a 3000. He's over in, I think, Netherlands area or Denmark. But he's doing a 3000. Paul wants to do a 3000 tower board, which is even more ambitious. But I don't think he's gotten any traction with people who are interested in this. So this is an example of SMT, if I can get it focused.
Ooh,
So you can see this is SMT, and a grain of rice is about the same size as these.
Yeah, that's
And here we're looking at all resistors,
micro resistors.
and I'll point them out. So these are all resistors. These are, I believe, so the way these are described is by their size, and these are, I believe, 0806s or 0804s. Can't remember
I
which
can't
one.
see the number,
Which-
but it's,
And the resistance is actually marked on them.
Yeah.
So you need.
you need
no,
magnifying glass.
No,
to
my
get it
my
over.
microscope can get a little bit more dirty than this. We'll zoom
And
in.
of course, it needs cleaning up now.
No, refocus.
Oh, there you go. You almost had it there.
All right. So
2280.
no, it's actually
Or
that's
22,
220.
22.
220 ohm
220.
resistor. Yeah. If it was 220, if it was 22R1, it would be 200 or 2200 ohm resistor. So it's like the number of
That O
zeros.
looks like an R.
So anyways, yeah, these are the resistors. These are capacitors. They look almost identical. See where they're marked C503, C5. These are 100 nanofarad, not microfarad.
Microfarad.
100 nanofarad capacitors.
There's
So believe it or not, these look really scary and intimidating to a lot of people because anyone who's not worked with them,
1K.
in my opinion, they're actually easier to work with than through hole because all the business is right there. The only challenge is the optics and having a steady enough hand to be able to work with it. The beauty of it is the pads, the way they're designed. I'll find an empty pad. The way the pads are is you would actually apply solder paste, which looks like this. This is a tube of solder paste, and it's kind of a liquid with tiny little balls of the solder, and those tiny balls, which look more like a paste to the naked eye. You apply it like you would be like spreading spackle on something or toothpaste, and you put your component on it, and simply by having your component smashing in between the paste and the board, it creates surface tension that pulls them together. And it's I mean, not enough to where you could turn it up and all the pieces won't fall out, but you could probably put all those resistors in, hold the board up, and they're not going anywhere. They're held in by surface tension. So to do the application of that, once you have the component sitting on it, you're going to either dump some heat on it, depending on what component it is, or tap it with a little soldering pencil to basically molten one of the pads that's got paste on it, and that will cause it to come. Or using a hot air gun with a very low air, because you can blow these little parts off easily, with a very low airflow, you can apply heat to the board. And one thing I talked about when you do that, you want to do what's called heat soaking. So you want to warm the whole board up, and then start focusing your heat on where you want to work. But what is amazing though is these pieces typically will fall right into place. They'll snap into their location of where they need to be. They'll self-align, essentially.
I did notice on the back side of that board, I noticed that the empty slots are color-coded, where it had positive and negative area.
I'm not sure what you're talking about. We're looking at the back of the board right now.
When you flip it over on the back side,
Let me see
where
the
you
old
see the
board
empty
for a second.
slots, there's the pads have two colors.
That might be a visual thing. They're all made of the same material.
Well, I'm talking about where the resistors and capacitors fall into place. It looks like a two-tone where the pads, where the legs supposed to go into.
Oh, okay. I'm not sure. I see. It might be a lighting thing.
Yeah.
So as I was applying these, Brian, you were like, "What? I didn't know you could do that." Literally, you get a little bit of that solder paste on there, a tiny dot of it, and then you carefully place the component, right?
Real carefully.
Yeah, very carefully, and you can line them up, and then apply heat to that area. And you want to keep the basically what I'll do is I'll use the hot air gun and I'll circulate the heat at a very low airflow to kind of warm up the whole area. And then when I'm ready to, I'll get a little bit closer and I'll dump heat directly on the part I want to work with, constantly moving this so that we're not creating a burned spot. But if you heat it up evenly, all the parts will just go, they'll kind of just settle into their right place. And as long as they're set up initially, roughly like this, these could be at slight angles to each other, but because they're all being heated at the same time, they'll pretty much will self-align. Now, ICs, a little bit different story. The approach for doing those, you would apply the solder paste. Some people don't do solder paste at all. Some people will put the chip on and then use a little bit of solder on the tip of their iron and just tap it. Another technique is to dump a whole bunch of solder across the whole row. Like they might put, once the IC is on, they'll put solder down. There we go. They'll put solder down the whole thing. Just dump solder like you would doing a through hole. And create a big old fat bead, and then they'll clean it off by using a drag method, essentially dragging the soldering iron after cleaning it multiple times
In between.
and the soldering iron will pick up the heat will draw the molten solder to the soldering iron, and once you have enough on it, you just clean it off quickly and repeat that a few times. And flux is incredibly good for making sure, like you might need to reapply flux to it to get that solder to flow out. But that way you're essentially creating bridges so that you can remove them when you're doing that approach. I don't care for that method for smaller stuff, but for bigger ICs it's a little bit more of a practical solution. Before I ever started working in SMT stuff, though, I went to Goodwill and bought routers and cable boxes and VCRs and stuff, and I just remove stuff, reapply stuff, remove stuff, find out what works, what technique works, before I ever started touching, real gear. Now, somebody who's been doing this for years might be like, all right, I already know how to do all of that, but I needed to learn, and I think most of you guys have at least some minimal experience with soldering, but maybe not extensive, and that's a good way to refresh your skills. You're talking about not doing it for 5 years, learn new skills like SMT work. The attacking Goodwill $2 cable boxes isn't really something anyone's going to cry over.
I have some.
I don't want to. I don't want to.
I can play with them.
Okay, you play with them. You can play with them. And I'm not going to fix it for you. Okay?
No. I don't want to do it.
So the capacitors for these, though, we saw a surface mount capacitor a moment ago, but the capacitors for these are a little different. These are electrolytic capacitors, and market prices right now on these are ridiculous. And the reason why they're ridiculous is iPhones are sucking away the global supply chain of a lot of the materials that are used in them. So some of these go for what used to be like 10 cents a pop, are now going for $2 or $3 a pop. So this is a surface mount electrolytic capacitor. This is what, this isn't completely new technology. This is what's on our 3640 boards. It's what's on your A1200, your 4000s. I think 3000s have them. I'm not as intimate with them as maybe one of you guys might be, but I think SMT was used on a lot of stuff on the A3000. I don't know how much of it might be these kind of capacitors or through a hole. Anyway, you can see they are marked. They're polarized. This is a 22 microfarad. Usually that's date codes and special information regarding the model, depending on who the manufacturer is. But the polarization is important. That black mark indicates the negative. So the negative lead is over here. And on some of the 3640 boards, as we talked about, these were backwards and or installed backwards, or something was backwards. I can't remember exactly what it was.
It was a dual problem. The printing on the motherboard was wrong, and they had to be turned the other way. So a technician would see the plus minus, follow it because
that's what it looked like, yeah.
And it was wrong because that's why it was backward. So it had to spin it around. So I have a really nice PDF about it, and can share it with everybody.
I wouldn't mind seeing that. I probably have seen it, but it was like ages ago.
Yeah,
it's a really old,
it's
Amazing Computing or
89 maybe.
Oh wow, that far back.
No,
because the 4000 came out in '92, I think.
4000 came out in '90.
Okay, Google.
Somewhere a long time ago.
We'll figure that one
That's
out.
3000.
Somewhere a long time ago.
Pretty sure it was '92 because I was in Texas and I got Commodore sent our club a 4000 and the club president said, "Here, you do it. This is yours." And I got to play with that for about a month before a show, and then I got to demo it before they were released. That would have been '92, '93, near the very end, but they hadn't actually shipped them at that point. Anyways, so the legs on these are real tricky because you can't solder these like you normally would. This is why it's important to align these appropriately to, and I'm not going to do this board because I want to install a lot of the quad flat packs first, but they get installed. There it is. I'm having trouble seeing. They get installed on these guys right here. So you can see this one's pretty clearly marked that the positive is right here.
Yeah, C105.
Yep. And this is 22 microfarad. Now, usually, they're having it actually marked like this on the board is super rare. A lot of older gear doesn't show you that information on the silk screen. It just says C105, and then you have to look up in the book,
And
C105.
that's one of the things I'm almost complaining about. So he had them, part of the thing was to have them printed.
Right, to help it. It makes it a lot easier to build. You actually know what. And by putting the right component, like these are 74 series logic ICs.
Yeah. Or the gals or all the rest of the stuff, yeah.
Anyway, so clearly this one's positive, and we could actually ohm it out just like I showed you earlier with my meter, and we could do a beat test on it, and I should see this guy beeps to ground. Ground is probably, I think ground pin on this one is right there, if I'm not mistaken. That's at least one of the grounds I can check it against.
Have you built a complete board yet?
No, not one of these. No, I haven't. No, this is.
Now, is this more fun, building on a board like this?
It is a lot more fun, yeah.
Than repairing an old
It is more fun because you can get more zen. You're doing something that isn't likely to present you significant challenges. Like, oh, I didn't expect that to happen. Whereas building is kind of like putting together a Lego kit. It's, you know,
follow A to B, follow C, and you just go.
You're just doing them, and it's actually, for me, it's kind of like a Zen experience. A couple hours go by and you don't realize, like, oh, wow, I just burned up a couple hours, and I've been focused on this, and it's been fun. You know, and I'm hacking because I haven't turned my fan on. So, anyways, you have to pay attention. I'm going to work on that bad board here.
Now, why do they call it a 3460 as opposed to the 3440, 3640?
Because that one is the 060 version.
Is it set up for the 060?
Yep.
It doesn't have to have a little daughter card?
No. No, it's set up for it perfectly out of the box. The only thing is, so you know what a PAL is? A programmable chip. I can't remember what the A stands for. It's a logic. God, I'm drawing a blank. I usually know it right. So there are a couple PAL chips on this that are what make it work with the 3660. They had to be custom programmed. Dave Haney, who dumped the ROMs, actually dumped all of the PALs for the 3640, and he's made them available. You can download them and program them yourself if you have the right equipment. But it does require a slightly modified version of the PALs that were done by Commodore in order to work with the 36.
So when you get this particular little board, you actually have to either get those PALs pre-run,
right,
or you have to do it yourself.
You have to do it yourself, right? Now I got mine done by a guy who already programmed it.
And all you got to do now is solder
I
them
have to
in.
do the installation, right? I'm still torn whether or not I want to do sockets or directly mount them, but that's my prerogative at this point.
So and why would you want to put a socket there, since once you put an 060 there, it would be an 060
Well,
as opposed to 040?
To make sure if I need to take the PALs off and if there are problems with them when I do the initial installation, if one of the PALs is bad, and I replace
it was
the PAL.
programmed incorrectly.
Yeah, and I don't know the answer to that. It's just as easy to remove it. So that's the give and take.
Sockets make a difference there if you want to play.
Yeah, but I've been told by people who built them to say skip the sockets. So some
Is
people,
is it someplace on the board that you can actually reach it really easily?
No, to do the socket. Well, to do the IC, I mean, it's one of these PALs right here.
At the very corner.
To do the socket for it, it's actually sockets for these are not as easy as you think, because if you're doing it by hand, you kind of have to go from the inside of the socket out, because the pins actually reach inward, and the housing for it. So you're really only making contact here. In order to solder it, you're going to have to solder it from the inside of the socket, the hole. It's either that or you do a reflow, and I don't have a reflow on it.
I wasn't aware that you needed that particular technique.
If you look at an Agnes IC, and you can imagine any kind of PLCC, that's what this form factor is. If you look at the Agnes IC, and you take the chip out, when you look inside, that's the only part you're going to see where.
And those are where
I'm not talking about the through-hole version. I'm talking about the surface mount version, like you'd have on 4000. So forgive me, I kind of, because you do have a through-hole version of PLCC connector or sockets. To do a surface mount PLCC socket is a lot trickier because of where you have access to the actual copper. That's the problem there. If you're doing it by hand, if you're doing it in a reflow oven, again a technique similar to the way I talked about with the resistors and capacitors.
You lay the thing.
You lay it on there. You're
let it melt.
reflowing it. As long as your alignment doesn't shift, it's fine. But I don't want to risk doing that myself.
Are those little holes micromillimeters?
They're very small. You can't get a needle through those.
No.
Which little holes?
The vias. So those are vias. What they do is they allow the trace to continue through the board to the other side where they come out. And somewhere for each one of these holes
That would have
the hole is on the other side.
0.01.
You know, it's small. Way smaller than I can work with.
Said there's 0.01. Wow. That's
So the
cool.
big problem with vias is like on the 4000 where we have battery contamination, so they get in those vias. And the vias, which if you want to think of like a rivet, it's got a cap that on one on the top, and a channel, and then it comes out. It's kind of like a cap, or that's what creates that ring. So for the contamination, that's where if it starts corroding on the inside, it can short between the layers, causing significant problems, or it can short completely where it won't, or it will disconnect, so you can't pass the voltage through it. So on my 4000, I actually had to drill out holes from all the battery contamination that was in the vias. So literally drilling it out in order to get all of the crud out. Not an ideal situation. In some cases, I had to pass like thinner legs of metal than this. I had to pass that through the board in order to carry it. It was either that or running a bodge trace from the top around the sides back to the underside. None of those are ideal situations. But they're all what you do.
That's why Paul went so crazy. Ultimately, say, forget it. I'm just going to make the board
because it's a lot of work. And Paul being a pro at this, he's people were always sending him boards, so he dealt with probably a lot of worst case scenarios.
All batteries.
A lot of worst case scenarios because he became the guy who does that. Mm-hmm. And I don't think he could say no for a long time. But finally, it got to a point where I think it wasn't economically viable to keep repairing them.
Because it would take 80 hours to do one board being destroyed, as opposed to now he has the board and says, the thing is, all the parts for the board,
right,
including this one. How many parts separately are on that board?
Separately? You mean like individual components?
Mm-hmm. 1,000?
No, not thousands.
Probably 500.
60?
200.
60 to 100 maybe. I don't realize. I've not done a part count on it, but you realize most of the space of these boards is taken up by these big PLCCs and quad flat packs. So there's, each quad flat pack has one decoupling capacitor. We're looking at that right now.
Mm-hmm.
So that's not really that significant of a number of parts, but it's a couple hours doing it by hand. Still a lot less time than fighting and losing the battle against corrosion. Because you can look at this thing and aesthetically it might be awesome, but there may be active corrosion still going on the board. And that's why on this 2000 I stripped it down as quickly or as much as I did, and I went beyond what was visible damage, chasing after the hidden damage and or what it's going to corrode to next. So it was all a matter of trying to mitigate as much as possible. Did I get all the corrosion? I honestly don't know. Time will be the agent that tells us that. The idea was that you're mitigating the damage and trying to control it by reversing some of the damage that has been done, but you're ultimately, there's still corrosion occurring if it's under an IC, if it's somehow dripped to another part of the board. So lots of potential issues with that.
So other than the pinpoint soldering by hand,
Mm-hmm.
one of the things is about flow. What does it take to do a flow situation or a reflow situation?
That you typically would not do that for a rework. In this case, we're doing a lot of rework, but in the case of doing board assembly,
Yeah.
that the reflow in manufacturing processes. I mean, once they have the boards done, they use a pick and place machine to put all the components. They first apply the solder paste selectively using a robot, and then they place the components on the solder electronically, so that all of that is done through automation, and then it's transferred to a reflow oven where they'll have a particular thermal curve that was, a lot of engineering and maths went into it to come up with a thermal curve to basically turn that solder molten long enough and at a high enough temperature, but not so hot that you damage the components that you're installing. And all of that is based on whatever your lowest failure point component is on the board. And then throw it back out on the other side. Then you might have a technician do some of the manual stuff, like maybe, I don't know if this is the case, but the through-hole components typically are good parts that would need manual work. Notice that, so this is a Commodore one. Notice that there are no components on the back side of this. Whereas this is meant to be built by hand, not through a robot. There's components on both sides. that's to overcome space limitations that allow it to have a lot of the graphics that we see, allow the parts to sit nicely, and also transition from some of these big honking things like these resistor networks here, that these get turned into rows of resistors. So there were design considerations that Chucky went through on this that was to overcome some of the shortcomings of being assembled by hand. If this were meant for manufacturing, you really wouldn't want to do SMT on both sides. You might do SMT on one side and all of your manual through-hole stuff on the other. There are manufacturing processes that can do both sides, but the method is typically going to be SMT float on one. So I'm in a probably a time deficit because we've sucked up a lot of time. But I'm also, as Michael pointed out,
or are we just talking?
Michael pointed out I have a gender problem, and my second soldering pencil or iron doesn't. I can't power it right now because I have a power issue with that. So normally what I'm going to do is when you're doing these surface mount capacitors, there's a bunch of different techniques. There's some really violent ones. Some people swear that you can just rip them off by twisting them. Now, you might say, but you know, if done properly, it can actually achieve no damage to your board.
And be done quickly too.
Yeah, very quickly. You can, you know, I've seen videos of people doing that. I wouldn't dare do that myself because number one, done properly is the key word there.
Yes.
And it also depends on how strong your pads are.
It is. So the big problem is these pads damage pretty easily, particularly when you dump heat in them, but also when they have corrosion. So because these are subject to
They're even weaker.
They're much weaker in some cases. So and because these capacitors can leak and the damage can be invisible, you won't see the damage aesthetically, but there may be physical damage or electrical damage to it. And the pad may be compromised by having the contaminant actually break the bond between the pad and the PCB. So the trick is to remove these without damaging the board itself, because as I mentioned before we started, the way you repair them is actually cutting. The way I've done it before, when I've had to repair a pad because of corrosion damage underneath the pad, is you have to first extract the bad pad or what's left of it,
and then put a new pad in.
And they're copper, right?
Yeah. What's that?
They're copper pads.
Yes, it's pure copper, so it's a copper foil. It's like a copper foil material. It's very thin, and you can go and buy very expensive at the manufacturing and engineering rework level. If I were a commercial business and doing this professionally, I would probably be spending hundreds and hundreds of dollars just on pad repair kits, where you are buying copper traces that are pre-cut from a library, and you pick the one you want out and lay it down, and if it fits, you apply epoxy and cure it. To do it on a budget, it's a little different. I went and bought some copper foil off of eBay, and I carefully, with an X-Acto knife, cut a pad that looks, just like one of these.
Wow.
Not the rings, but the square rectangular.
The rectangle,
pads.
yeah.
And not in case you didn't notice, these are pretty freaking tiny, and it's hard to cut a square that or a rectangle in that shape of copper foil. This copper foil naturally wants to destroy itself into a crumpled mess.
But you did it because you were wanting to experiment on your own, or because you needed?
I needed to rebuild a pad that was damaged from battery damage on my current 4000. Actually, is the one I.
At that particular point, with your expertise, wouldn't it have been more cost effective to just buy one of Paul's boards?
So no, actually it wasn't, because $5 of copper bought off of eBay.
Yeah, but how many hours of cutting and fitting?
Believe it or not, I did it in an evening.
Okay.
I did an evening with an X-Acto knife, and a couple failed attempts, but enough to get one right. With not just the rectangle part, but you're actually building the leg. You have to build a leg too. So you're building like a rectangle with a leg, a very thin leg.
It would be like a filament, wouldn't it? Was that
just about? But with the microscope and an X-Acto knife, and not a lot of caffeine that night, so my blood pressure is not going crazy. I was able to cut several of them actually, and I made spares just because I haven't used them, but I made spares just in case I need to. But that's, to me, that's actually not the hard part. The hard part is having it bond to
The board.
PCB. Yeah. So for that, I had to reach out to a commercial company and ask for a high temperature epoxy. And that's because your typical Home Depot epoxies, your super glues, they're not going to work. They will work, but they will instantly, as soon as you apply heat to try and attach your component to it, they're gonna smoke, they're gonna separate, they're gonna curdle, they're probably gonna produce some kind of carcinogen, and you'll die. But if you get a high temperature epoxy and apply it a very, very small amount, I mean, it's an insanely small amount but it's expensive, like $30 for, epoxy that you may use only once or twice. But I needed to do that repair, and it worked. And the cure time was like 2 or 3 days. So it took a long time before it was ready for me to work with, or where I was actually, I'd say a long time before I was comfortable with attacking it with my soldering gun.
Because you wanted to make sure it was cured.
Absolutely, yeah. And the first attempt I did, it failed. So I went at it too quickly. So maybe the hardener mix wasn't proper, or the ratio wasn't exact, but it does have to be pretty precise in order to get the set and cure.
Cure properly to work over time.
Right.
Well,
So-
see, now, it sounds like something that's doable when you're willing to play with it, and it's
Yes.
also within the cost range. But the next bigger argument is, if you spend a slightly small amount later, you can have a clean board all the way through.
Right. Well, so when I actually did this, I wasn't aware that these new board designs were coming online. This is just about a year ago that I did the pad replacement, and I had heard of Paul. I mean, I knew Paul was like the guy who does 4,000 repairs, and I considered sending it to him. But I figured out, I've learned a lot. Let me go see what I can
Try it
apply.
yourself, yeah.
Right, I'm never going to beat Paul. Paul's got 20, 30 years of experience on me. But a lot of this is within the reach of somebody who wants to learn it. Part of the reason, as I mentioned before, is accessibility of information is more prevalent these days than it ever was. So guys like me who don't work this professionally, don't do this from a professional level, or are not educated on it, can learn how to do this, learn the skills and trade aspects of it. Again, I'm not a pro. I don't want to be a pro. I would hate it if I became a pro.
But you're just an amateur.
But I can do this. I can do this with a degree of confidence. Maybe not the breadth of experience that somebody's been doing it, like Ray Carlson on the Commodore, or Paul on the Amiga. But this is something any one of you guys with the right tools and patience and a steady hand could do. And there's no magic to doing it. But when you make mistakes, sometimes you pay for them. You have to do a lot of rework. In the case of the pad damage, that was damage from capacitor leakage, or from battery leakage. So I ended up having to replace it. So I'm talking to you, you apply a very tiny, I used a toothpick, and a tiny little dot of that epoxy, a dot on the pad, because remember, your idea is to have it pressed so thin that it's bonding the copper to the board, and it's thinner than any kind of sheet of paper. I couldn't quantify how much it is, but you want to let it fill the pores of both the copper and the board, and leave nothing distance-wise in between the two. And to do that, getting it laid out, putting a piece of Kapton tape, which is Kapton tape. You guys have probably seen this copper impregnated tape. This tape is really useful because it has an incredible ability to reject heat, to be able to be working around it with 350, 370 degrees Celsius, a hot air station, and this holding other components from blowing away. Or shielding. Like if you needed to shield some other part of the board, this would be a part of that solution.
The adhesive that's on the backside of that can actually handle the heat.
It can. It does. It doesn't give. I found it does. It doesn't like alcohol being dumped on it. It doesn't necessarily like flux being flowed too much on it. But generally, that's only if you're doing rework of your rework. First application, dumping a lot of heat on it. These things the tape does hold. It's very efficient And
And it takes the time consuming away for certain
it
levels.
does. It absolutely does. So what I did is I laid this on top of the curing. Now the drawback is you're kind of cutting off the airflow that might be assisting some of the curing. So I actually set the board under a UV light and let it soak in the UV energy, and in hopes that helped accelerate some of the curing, as opposed to leaving it outside.
Well, wasn't it a UV cure?
No, it was not a UV cured glue.
Okay.
But epoxies, and I found this out from working with my RC stuff.
All epoxies are UV cure, or kind
A
of?
lot of them accelerate faster. So it also, they work better depending on what temperature they are when you're applying them. So your cure times, you've probably seen your cure times differ from the winter to the summer, and almost all resin-based epoxies have that same property. During the winter, your cure time might be fairly short, or your set time might be fairly short, but your working time might be really long. And during the summer, your set time might be very long, and then your working time very short. So those two things are often in play. If you want to keep epoxy in a long curing state, you put it in a freezer before you use it, and it makes it more paste-like. And when you take it out of the freezer and you're applying it, it will be thicker. And if you want it to run and flow better, to create like a thinner, applying heat on it, not necessarily for board applications, just for hobby applications, other hobby, for model building or radio control, or I do drones and stuff. So that often is a way that you can make the epoxy work for you.
It's almost like a battery. You can actually put the battery in the refrigerator to hold.
Depending on what it is. Depending on what it is,
Yeah. and
Different chemistries. Different chemistries
Yeah.
work differently under different
Yeah.
thermal conditions. Anyways, so this is how it holds the pad in place while it's curing. Now, I mentioned before that I can't really do this part of the demo, and that there are different techniques for doing this. The best pro technique is to use a pair of tweezer. Well, tweezer. They're very. Jerry and I were talking about this before we met. Use a tweezer soldering iron, and it's one that dumps heat into 2 points at the same
On each
time,
side.
and you can maneuver it so that I'll emulate that with my tweezers here. You maneuver that so that you
Can touch both sides
touch
of both legs.
both at the same
to lift
time.
up.
Now, I don't have the luxury of that $450 Hacko soldering station with solder tweezers, but I do the next best thing, and that is 2 soldering irons, and pretend like I'm chopsticks. I've got, I will essentially maneuver both of them in a way that lets me make contact with the pads, and I've done this like 20 or 30 times, so I'm pretty proficient at it. But throw some flux on it first, that solder flux, dump some heat onto it, minimize the dwell time because these pads are more sensitive than these big honking Amiga 2000s and 500s. Minimize your dwell time so that you don't separate the pad while you're pulling the capacitor off, or damage the pads. That can happen as well. So a couple of seconds of contact molten solder, and then back off. Now, some of the heat will still be residual. You might want to come in and re-attack it. I found that this technique works. Now, solder tweezers, it's usually a one and done thing. Done. Okay, it comes right off. 2-pronged attack. I will, lightly tap, hold it for a second, and pull it away. Lightly tap, hold it for a second, and then, believe it or not, I get both of them molten enough that the cap will just wiggle off or start wiggling out of alignment. And usually, it's molten enough I can just flick it off, and it will free up, no problem, no damage to the pad whatsoever. But
That takes a little practice.
it does take practice, especially when you're doing something that you want to protect. And
I
keep.
can imagine waiting for it to go.
And then next thing you know, you're lifting a pad up with it. But so this board, I've actually done this board, even though it's already short to ground.
You thought maybe you could revive it by.
Oh yeah, but I
recapping.
realized it was short to ground once I took all the capacitors off, and I was still seeing short to ground scenario.
But then you did it for practice.
Yeah, I figured what have I got to lose at that point? So I just redid all the capacitors. I bought them to repair it, but I didn't know that I was going to be in
Yeah, it wasn't a loss of big dollars.
Oh no, but it also allows me, I can throw this board around and not care about it. And I intended to actually remove the capacitors. Now there's other techniques that involve dumping some heat onto it, which I could actually show that. Again, a hot air gun, these things can go up to like 480 or 500 degrees Celsius. Chances are good you don't need 480 degrees unless you're doing like VGA work, ball grid array, or stuff that has so a lot of VGA chips are on modern like PlayStations and Xboxes and
Actually,
computers.
the Amiga ones, the PPC chips.
Oh yeah, the PP Sun.
That
yeah,
would work with
that's a modern, but that's a more modern approach to interface. I mean, Pentium being modern. Okay, my thought process. So 1995 being
Amiga
a
one
more modern.
PPC is definitely not modern, but it's more
Right.
modern.
But it's not using pins. It's not using legs. It's using a VGA approach to
Yeah.
it.
Which is where the ball socket and resoldering fall.
Yep, so that's a different discipline altogether when it comes to soldering. There's VGA rework stations that are meant more for your guys who are fixing phones and modern computers as opposed to hobbyists. So there are probably hobbyists in that category as well. So anyways, I'm going to attempt to do this without damaging it, but let me find one that's not as crowded. This is actually kind of crowded to
Because
work
they're two
with.
together.
I would have preferred to do this differently, but
What about the one in the bottom corner?
yeah, you're right. That's a good candidate. It might be a little awkward because he's on my camera back a little bit. I'll see if I can. So what I'll do is I'm gonna have to do this with my glasses here. So again, when you're using a hot air station on a PCB. Let's see what didn't pay attention to what temperature I've got it. 370 right now. I think that's probably a good working temperature to start with. Airflow is a little bit high. I can hear it. I was probably using it to warm an area up as opposed to. So what I'm going to do is try circulating it around both sides. I don't know if you guys can see this.
Yeah. Oh yeah.
All right. Let me put my glasses on. I'm just trying to focus.
Oh, there it's flowing. The flux is flowing.
Yeah, the flux is flowing, but that solder's not going to flow right away. So ideally, I'm going to have to back the microscope out and refocus because it's going to be in my way, and that's going to get really annoying.
That's okay.
All right. So these tweezers that I have, they have ceramic tips. Ceramic is a good material for making sure that you're not dealing with too much thermal shock. Now, right now, my airflow is a little high. I wouldn't do this on.
Yeah, you can see it pushing the flux around.
Right. If you were doing this on resistors or capacitors, you'd run the risk of having them fly away. So lower airflow might be appropriate. If it has any mechanical resistance at all, it's not ready. So
Yeah, it should just lift.
it should just want to come off, but it hasn't flowed enough. But I haven't concentrated a lot of heat into that area. I've been worried more about getting a good soak on the board. I don't know if you can see that, but it's getting silvery.
It's getting there.
There you go.
Again, not my preferred technique. I like the tweezers method, or like the chopsticks method, I call it, right? But that came right off. No damage to the board. We will want to clean that before we reapply the
But at least it didn't
capacitor.
ruin the pad.
Oh no. The only way you're going to ruin a pad is if it wasn't ready to go and you're pulling at it
And
too
you bring
early.
the pad with it.
Or the pad is damaged from capacitor leakage in the first place. So those are the only two scenarios that I'm aware of where you run a risk of damaging your board. That's why if you do the techniques properly, you're not going to encounter that, right?
Any technique can work perfectly if you have it set up for you and practiced.
If you're comfortable with the technique, and somebody who's doing, probably Paul has his preferred technique, and I think he probably uses tweezers because I think that's probably that's the pinnacle that I'm aware of. That's the pinnacle point of what tool set, if you have available to you, would use. I might be wrong about that, but you can get in there at a very precise point. Instead of dumping heat to an area, you're dumping heat precisely where you need it, and that's different than an airflow. Yeah. So I'm going to say I would need to clean this first because I don't know if you can see this very well. Let me check my focus. There's solder on it, and that's actually going to get in the way of reapplying. That's actually a lot of solder, believe it or not, by my definition. So I'm going to give it a little bit of flux. Here's where heat is
You know,
critical.
that's
Remember
flux.
how I was at 360? I'm going to go down to 320 now.
That flux looked like
Actually,
a little glue.
315.
Already micro drop. The reason that we're seeing it the way we are is because of the magnification.
Yeah.
Yeah. But we didn't lose that resistor right next to it too. So, I mean,
I thought that was really good.
no, we got heat in the right spot. That was the critical thing. And most of the time, I was about an inch away,
And you were angled.
and I was angled, which is not ideal. I want to be directly above the part. When I'm doing it, and I don't have a camera. I'm going to be like on top.
Really?
Of it.
You'd be
Yeah.
straight down?
Well, no, I'm going to be looping around the capacitor
Mhm.
so that I'm warming up the entire area around
That's
it.
a pretty small loop.
It is. Yeah, it's a very small loop. You saw I was doing
Yeah.
like this. It was a very small physical action that I was doing.
I would have thought that angle was what you normally do to push the air in one direction.
No, actually, no. I like to have it coming directly on top when possible because that minimizes other components getting excess heat dumped onto them.
Yeah, in this case, of course, since it was a corner thing, I was assuming you were.
I could have done this on these as well. These ones like the one by
Mhm.
the socket, but I'd prefer not to. Just even though it shouldn't matter because this board is dead. Let's see. I do plan on getting a few parts out. Oh, we were talking about that.
Oh, you can take the parts off for
By the
your.
way, that's a socket right there.
Mhm.
There's nowhere to solder from the outside. You have to solder from the inside of that. So just to loop back to that point earlier.
Mhm.
Now, how long would it take you to take all those components off of that board?
The only ones that are worth saving are the gals. These are gals.
The
not
gals with
pals.
the pals.
Yeah, the gals and the pals are the ones. The programmable logic.
Even the timing thing is easily erasable.
I would say buy a new because crystal oscillators. That's what this silver can is. They are subject to aging too. That they have a lifespan on them. Now, I'm not saying it's not going to work, but they're more subject to aging than a lot of other passive components.
And why work so hard? You can just replace it for pennies.
Yeah, for $1.50 from DigiKey, you can get a 50 megahertz one or 61 and see if you can push it.
That's is that a 50?
That's a 50 megahertz, yeah. So remember, you're not necessarily clocking the CPU, you're clocking the board.
The board.
Yeah. So that wouldn't be worth saving, but so these guys right here, unless any one of these is special, and I don't think any of them are.
What those
These are
chips
logic. When you see 74 in front of a chip name, that means it's a logic, and then the numbers after it determine whether it's TTL logic or CMOS logic. It kind of sets the voltage if you want to think about it that way. Like 74 HCs are I think CMOS, LS is 74 LS is TTL, like you find on Commodore older 8-bit machines. The HCs and FCs are typically what we're going to see in the more modern 16-bit machines.
My question is, what is the second set of numbers where it's 543T5 or 5?
I don't know, but I can tell you that the bottom number set is a date code. This means it was made on the
1993.
ninth week of 1993. So I just know that that's the date code. I have no idea if these are lot numbers, maybe. 543 TSO, 543 TSO. They're all the same.
Yeah.
So anyways, these logic chips, most of these logic chips, here's something pretty freaking amazing. Especially the dip ones even, what dip or the socket like you have on old school with the big long legs. The non-surface mount through-hole style. You can still buy virtually all of these logic chips.
Well, they made millions of them.
And they're still making. They're still made to this day. I ordered replacement for the Commodore 128 I'm working on right now. New manufacturer, Texas Instruments, is still making. These were made by probably Fairchild Semiconductor, but they're still making because they're ubiquitous.
The damn things?
Yeah, in fact, Texas Instruments posted a profit. I think this. No, they're between Fairchild Semiconductor and Texas Instruments. Those two have been. They've pretty much both. No, they're still doing it.
They're still.
Well, Fairchild's no more, but TI's logic stuff is making a lot of stuff that Fairchild used to make, and the logic is simple. Bus transceivers, AND gates, NOR gates, controlling flow logic essentially. And there's a lot of these on an Amiga 4000, On a Commodore 64, there's a good couple dozen of these that are scattered. They look the same as
So you
RAM
can.
chips.
So again, with the board, instead of trying to take everything off your old board, you just buy.
Buy new stock, yeah. The only thing I would think that would be worth it would be those pals and gallons, to be honest with
Yeah.
you. Because I think they're still...
If they're programmable, you need that flash square.
Yep, exactly.
I'll be damned.
So let me clean this up. I said I would do that real quick. So I put a little flux on it already. Let me clean my soldering iron, which has been patiently on standby. And grab my solder braid.
It's like, cool.
And the idea is that
I see it. That's okay.
Just sucks it right up.
Sucks it right up.
now one thing you have to be careful about when you're doing
Don't put it on too long.
Yeah, put it on too long, or that you start to lift the braid up
Yeah.
and it's already solidified because you didn't put enough heat into it and it's not molten anymore. And if that happens, you run the risk of pulling the
pad.
the pad out
Pad out.
with it. Yeah, and that's a big risk that you have to watch
Because
out
you'd be
for.
breaking the connection.
Right.
I don't know too much about electronics, but I do know enough to where I do know you do not want to do boo-boos.
So
Because you're
let's
doing
get
your
some
boo-boos,
cleanup.
you have to redo your do it thing.
Oh yeah, but
And
there's
that's
also
time consuming.
there's also times where you do boo-boos that are not fixable or not cleanly fixable. You have to work around them by running wires or whatever. But here we
Yeah.
go. We're gonna put a little bit of this denatured alcohol on it.
Denatured alcohol.
Yeah. And there you go. That looks pretty damn good right there. doesn't
Damn,
it?
that's cool.
All right, let's
Just let it dry out a little bit. after
we'll
you
help
do
it out with the dry
the
side.
dry side. And I will tell you one thing. Some of the guys that I talked to a long time ago,
Nice.
they always like to reuse that damn Q-tip because,
Not me. I go. I
just
buy
buy
those.
box of
I buy
Q-tips
those
and-
whatever 1,500 count.
yeah.
I'll be honest with you. I had to yell at my wife because she picked up some Q-tips recently, and they were store brand Q-tips,
Oh, no.
and they left fibers. And I'm like, what is this garbage? They're leaving fibers. So I'm like, okay, branded Q-tips only. Now, okay, so here's the deal. There are real
Real Q-tips.
cotton buds that are used in labs that leave very few fibers behind them.
Yeah.
They require less management of spinning it to make sure you're kind of twirling it and sucking up all that. But again, when it comes down to if I'm doing it professionally and I'm getting paid to do this, I might invest in that. I'm doing this for love, so I'm going to use the most inexpensive materials I can find to do the job. And a Q-tip does the job. But as we've learned, store brand Walgreens or Walmart Q-tips were just not cutting it for me. But I've literally gone through 500 Q-tips in about 3 months. So, and that's all from just doing not just board work, but other hobby work that it comes in.
What Q-tips do you recommend for other people to use that does not leave fibers in it?
Let's see. I actually have.
Because I know the Q-tip company, they do make
So
three different
Kenny,
types of varieties.
this is not really a Q-tip, but it is a bit of a higher end wipe. And this one's actually been used, so it's not a very great example. But if you look at this, this
Oh,
is
wow.
this
That's
is not a
micro.
Q. This is not
Yeah.
a. This is closer to a makeup brush.
Yeah, that's a micro Q-tip.
If you guys know, it's not really. But I'm having trouble getting a good focus. Let me try this.
At least that's what it
Look
looks
kind of like a foam head.
It is more like a foam head. Now I use these. Yeah, a little
Yeah,
bit.
that looks like
It is a foam, not
Q-tip
hairs.
itself.
Right.
But this is a very good tool for cleaning like drive heads or optical. And I use these pretty sparingly for that application when I want to.
They're costly.
They're not too costly, but they are more expensive by.
Then Q-tips.
Well, if you're going through
Yeah.
500 a month or what
Yeah.
have you, they'll add up.
So, and I mean, what I'm trying to do is get up gunk, and this is a good application for. This is probably better off at, saving for the good stuff.
Yeah.
But for most rework that I'm doing, it's Q-tips. All right. So, anyways, does that answer your question?
Oh, yeah.
You've been answering lots of questions.
Okay, so so we talked about there are different techniques to apply or to remove a component, but also there's different techniques to apply them. The one that you could do very easily is to get a little bit of flux on it. And by the way, we cleaned that while you were gone.
I noticed.
Just to get it on there very carefully, and then I shouldn't do this by the scope. Align it so that the metal's legs that we saw on the bottom match up to the pads. And the other part of that is to watch polarity. We mentioned that too being a problem. The problem with that is that it can cause, well, it's easy for you to knock it around. Another technique might be to use a hot air station. You could, just like we got it off, we could use a hot air station to reapply it.
Well, the problem with that isn't it that it will blow off?
It could blow off. That's why getting it to a good temperature before you put the part on actually is probably a better idea. Or you can just do what I do, and I've gotten kind of lazy because this is my quick and dirty. And
Which is good. Those are the good techniques.
well, yes, maybe. I don't know. I'm not going to say that any one of these techniques is not bested by a real pro IEC certified soldering specialist. You know,
No, the main reason the pro has the tools
Yeah.
and he has the experience. You know, if you do this 5 million times, you just it's easy.
you know, let me clear this out a little bit.
But yeah, it's as long as he has the proper tools and the money, he'll buy
No,
exactly what
practice.
Yep, practice.
and practice it and all that other stuff at the same time.
It's the practice that does it.
Being really stubborn, kind of like.
The stuff in the tip is old, melted.
Yeah, I think you're right. I'm just gonna try and squeeze out as much of that as possible. You know, another technique that helps is put a little heat on the board.
And the board will be warm.
The board will be warm, and when you apply this, it'll actually come out more liquid.
Yeah, that's like you put butter in your cooking dish. It's preheated.
I'm trying to put on cold margarine, and
Yeah.
you know,
On a whole
as opposed to a
board.
room temperature or softer
You
spread.
don't cook with margarine. It's good butter.
Yeah. All right, it's probably enough heat
Room
for now.
temperature butter
So
for a
the
whole
heat,
dish would
this
be
I just brought this
spreading out.
board up to temperature a little bit more, and now when I apply this, it should actually almost liquefy.
Yeah, you see the difference.
Big difference.
So now I could do this, the actual installation with the hot air station, but what I'm probably going to do is align the part as best I can, and then use a soldering iron to touch it briefly, very briefly, and melt one side. Now this is risky because you now have one side.
Hotter than the other.
No, you have one side that's been soldered. The other side's not. So now it's subject to any mechanical force. Like you bump it, you could potentially rip the pad very easily because both sides are not. They're distributing whatever forces you're applying to it. All right, ready? Here we go.
And you moved it. And you moved your forceps.
Yeah, did. Let me get some flux on that stuff. Being very cooperative. None of this configuration is my ideal, by the way. All the equipment is in all the wrong places. And
Well, thank you for bringing it all down and resetting it up. Now you get to go home and reset it up again.
yeah, this is not.
Still on
There we
to
go.
the left.
You know what? Let me reflow some, put some more solder. That's the problem.
We saw some of it evaporate.
That's your left-hand side right there.
And you know, I've done it. I can do these pretty quickly normally. but-
Well, you're under scrutiny. We're all watching you instead of you being in your own little world.
My own little world. I prefer my own little world. You guys are.
I do the same thing when I'm working on helping people rebuild board. They're sitting with me. I want to do it at my station on my desk. When they ask me to do it at their house, like when I help with build stuff is all over the place, and mine's in my little corner.
Well, my brother does the same thing with when he works on cars. He doesn't like backseat drivers.
And then people watching, looking over your shoulder, get you know, just discombobulate you.
So the end result, the idea is that we're going to create a nice fillet of solder on both legs and create a mechanically stable capacitor to board relationship. And part of that's making sure that the solder flows in enough that it creates that fillet we talked about, but not so much that it creates like a ball. If it does, we put too much solder.
And the little pyramid level style is usually on the leg, which is building up, as opposed to a pad, which is back to back.
Yeah. Well, even though if you look at the quad flat packs here, that these can be soldered this way by hand very easy, with some practice and to get this. But there's just enough solder that creates that bond. It's not just on it, but there's also a mechanical fillet that goes up to the leg itself where it contacts the board. So somewhere right about here, there's a soft fillet that goes between.
So it's like a bridge.
Correct. And that's the mechanical force.
Or what they used to call a flying buttress.
Flying buttress, yeah. It's the same. I guess it's the same kind of mechanical approach. So usually when I'm doing this, once I've got this in place, I'll apply some flux and then reflow both sides. Make sure you got a good temperature on that. It's good. 320 is good. So 320 is a little bit on the high side. You should be doing like 280, 290 on surface mount. But when you've got a thermal sink on a ground plane, that's when you need to offset that.
Do the various? I know there's various solders, leaded and unleaded. Don't they have an actual recommended actual heat?
Well, there's a melt point for
Yeah.
it, for the solder itself, but that doesn't take into account with how that energy is whether it's being dissipated at where the heat application point is.
Yeah, because when you apply the heat, of course, if it's an exact heat, if we have a tool that gives you an exact heat, the next thing is, of course, it takes energy to get it molten, and then there's a certain amount of dissipation of the heat as it goes through the process. But the question
There's guys
was more,
that do like math on that stuff to figure that out.
yeah. So, but the question, when you buy a particular solder, doesn't it recommend the heat you're supposed to use?
So, I guess in a pro scenario, yeah, I would, particularly with lead-free solders, which have different thermal profiles. I'm working with a traditional 64. Actually, this is a 6337, which is the tin lead balance between the two of them. And 6040, 6337, they all kind of flow really well at about 280 degrees Celsius right there. Boom. They probably have a specific melt point that might be 230, but depending on the tip, that's a big thing. Your tip is going to distribute more or less energy, so that's where you're going to have your variables or your assumptions. Yes, your melt point might be 320 degrees Celsius, assuming you're applying heat when it's not getting dissipated under certain levels. All right, so let me just quickly tap this. I'm essentially doing a cleanup job right now. Just reflowing it with some fresh solder flux on it. Since I'm right-handed, I'm having to mechanically turn it around on me. You notice that I'm just tapping it. I get like a second of flow and then I back off. I'm probably just being overly conservative, but I do not want my pad to take damage from that. Mechanically, it's stable. I got a little tug on that. I think we're good to clean it up and at least call this one done.
And luckily, you have an actual practice pad that's what would be similar to what you really be working on if you're going to do a 3640.
Right. I didn't have one
Practice
to work
pad.
when I started doing this, but it makes it better for illustrations. So.
I actually sent Paul a 3430 because he was using his 060 card to test people's motherboards. So I sent him an 030, and I said, but the problem is one of the capacitors fell off, and I don't know if the other ones are any good. So, but my mind said, what am I telling him for? He can just take them on and off.
He knows
And that's what he did. He just replaced the capacitor, and then he had to test accelerator that he for motherboards that he wouldn't have to risk his own 060.
That's good that you were able to do that too.
Well, I'd had it for so long, I wasn't using it for anything. So I just sent it to him. Actually, when he started, this is the other thing about the story of Paul. When he started, he basically needed lots of little things. So the club actually, through the Abyss and through me, gave him all these things.
A lot of things to get started with.
Yeah.
Yeah, that's good. Well, in some ways, you guys have done the same thing for me by Jerry rating the spare ICs. And now I've got a painter like this that's indexed with all the ones that Jerry took the time to pull and place in there. 4 or 5 Agnes chips and 4 or 5 Denise. And when I start looking at those 2000 boards, I have options. And I don't have to worry about, okay, well, I don't know if this chip is bad because I don't have a spare to work with. Or I don't have a board to test it against because I don't know what signals.
And in fact, that's the reason we put up with the early Abyss. And actually it was of course, it was Dan who said, well, I've got this place to do with this. And so as people were giving us stuff, we didn't just store them in garages and people's homes like we used to. And we started putting them all in one place. And that gave us the ability to say to Dan, I need a this, and he would pull it for us. We would then, swap and do that. So that's one of the reasons I was a little loath to give up the Abyss at some level, because once we give it all up, we don't have any spare parts or any especially for older stuff.
No, Jerry and Chris have them.
And in the case of stuff that we can't replace,
That's good.
Actually, no, it doesn't look very good. It's slightly off.
It's off.
It's off to the
about a micro.
Yep.
Micrometer.
And I think I would want to get a little more solder on that. So from a rework and reinspection, I would want to rework this. If I was looking at doing this, like if this board was not a dead board, I would want to rework this.
But this is great because then you can practice. You can say people next time
normally,
you do this.
normally when I'm doing this with these, and I'm about 2 inches away from it as I'm working. So I would have caught alignment issues. I'm not trying to stay out of the way of the camera. I'm in a completely unfamiliar scenario. So I get a lot of things that are working against me. Not that I'm trying to make excuses for it, but when I'm on top of it, I know exactly. I would have recognized this immediately and been able to correct it.
Yeah, it's not an excuse. It's actually you letting us know the proper technique that helps you do it right, as opposed to somebody like me I have really terrible vision now. I used to have super sharp vision, and I really fight seeing things. So, and the fact that demo things with cameras in the way, I've always had that issue with cameras and different things and people wanting not the camera in their face, or in their project, because it was in the way. But it had to be in the way in order to get the work done.
Okay, so this is actually a much better job right here. These are subtle fillets, little bolts to them, but they'll be functional. That's about what you would see from the factory. Probably looks even better when you get closer to a profile view. But yeah, all of these, like this is a factory capacitor install, and you can see they're not always great. I mean, these are done by machines that are spitting paste onto a board. And
Yeah, that one's a block.
Yeah. Counter, that might be more solder than I would like to see on my own stuff. But generally, as long as it's concave and not convex, it's a very good fillet. And as long as it's shiny, it's not a cold solder joint. The 60-40 lead solders tend to be a bit better in terms of their
It's
shininess.
so shiny you can actually see your reflection.
I'm waving.
Reflection, yeah.
I'm waving my hand.
You can see your face.
Yeah.
It's an elephant man right there. The leaded solder or the lead-free solders don't take on quite the same shininess in their aesthetic. And I've done some rework on boards that were leaded or unleaded solder, and it's a lot more work to do. You have to dump heat into the right areas at the right rates. They tend to require a little bit more thermal mass behind them, so larger soldering tips help too, in order for them to give up the solder. That's just what I've found from working with some of them.
Is it the age of the solder, or is it just the type of solder?
No, in that case, I'm referring to it's the type of the solder.
Type of solder.
Yeah, but the age of the solder, as I talked about it earlier, working Commodore 64s and 128s, and probably this 2000 is going to have some difficulty, but the 2000 gave up parts to me like I was just saying, hey, I want this socket. Boom, 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 it was done. Didn't need to do a lot of reapproach, didn't have a lot of legs that were just fighting me back. Didn't have to apply mechanical force to get a stuck pin. The gun pulled virtually everything out, and most of it just fell right out. Is that you? Oh, it's that kid. I thought your tablet was making that noise. So I think that covers just most of the stuff that we would go through for rework and repair of a lot of our components. Finding the problems is often the harder part. You know, you can replace capacitors, but
is that the problem?
Yeah, is that the problem? I mean, we know that. So the reason you're replacing capacitors is
age.
Is age, but it's also it should be preventative maintenance focused, not reactive diagnostic focused.
What about the resistors? Do they have any
Passives
issues?
and non-polarized multi-layer capacitors, no problems. Everything has a life cycle. Everything will die. The chemistry will break down, but when we're talking a lot of modern resistors and capacitors, assuming that they're not used or they're very low usage, they're going to last forever. Until the plastics start to completely break down. Yeah, and ceramics, which is the insulator on a lot of these things, isn't going to break down. It's going to hold up for everything breaks down.
We still find pot shards that last from thousands of years ago.
Yeah, exactly. Yeah.
I mean,
They'll be picking through our remains from an archaeological perspective, and they'll be finding capacitors and resistors and nothing else. Okay?
Or papers, or something like that. That is a 100-year life.
Well, the next question, of course, is more of a general discussion than more of a demo actual technique, and that is it comes back down to the I'm pro new as opposed to trying to spend. For example, what would it cost me to replace my motherboard now? Because, that's my fantasy. Brand new 4000 motherboard, which Paul essentially set up for me, but then I got to get everything on the motherboard before I can put it in my machine and rebuild it. So at that particular point, for me was, it's just not worth the work. And then even Paul, if I went to Paul and said, if I gave you $500, would you create me a new 4000 motherboard? And he'd go, not if I can help it. Because it just takes
time.
time.
I couldn't give an estimate to how much, assuming that you had every component ready to go. You didn't have to worry about sourcing. Sourcing is like its own nightmare.
Yeah.
What you do all the time, really.
Well, for my job,
That's what I mean.
For my job, I do component sourcing.
Allocate the time and components.
The time, once you have all of the components, okay, if you've taken that as a time factor out, you're still looking at 20, 30, and 40 hours worth of work. Handwork. Now, somebody like Paul probably has efficiencies he's discovered. If I do this before I do that, I can do it much faster. Or if I do all of these first, I can save 30% off the first time I did it. So he's probably realized a lot of efficiencies since he's done them multiple times. But at some point, the number of gains you can get out of efficiencies from doing it over and over again, you got to start leveling out. There's no more return on that. So he probably knows the magic number it takes him, which is 1.5 or twice as short as what I'm going to do because I haven't made one.
Which is the general discussion back to, is it really worth rebuilding as opposed you're working on labor of love for repair,
Yes.
which means somebody has something that they really want to do something with. In my case, what I've discovered, some of the people who come to me, because one of the things that happens because of the club is people come to us often